First is to discuss the transformative role of biotechnology in enhancing resilience to climate shocks, supporting nutritional goals, and driving sustainable agri-food systems. Apart from that, we will also be exploring opportunities for advancing regional cooperation and enabling policies for modern biotechnology in efforts to enhance competitive trade and healthier environments. And without further ado, allow me please to welcome Dr. Margaret Karembo, who's the director at ICER AfriCenter, to give us the welcome and opening remarks. Let's give her a round of applause, please.
Our PS. State Department for Science, Research and Innovation, Professor Abdurazak. Karibu sana. You have come from so far away and this could be your first event. So we hope that you bring all the energy and all the for us to move forward. Distinguished members of Parliament from East African Legislative Assembly, we are grateful that you are able to come and join us. We have, of course, our own here, the President, National Academy of Sciences. We have distinguished guests, experts from National Biosafety Authority. The CEO is right here with us. And we also have the Kenya Agricultural Research and Livestock Research Institute, organization, KALRO, and all distinguished guests, ladies and gentlemen. We have our farmers here. I'm so grateful to see farmers' faces here who have actually been working with us in this journey of biotechnology. Friends, all colleagues, a very warm welcome to this national dialogue on growing food in a healthy planet. The reason why we chose that theme is this week we have two events. We have the World Environment Day coming up on 5th June 2025. And we also have the World Food Safety Day. And we thought this was a good time to kind of warm up to this international event so that we can also see and raise our views as Kenyans on where we are as far as growing food in a clean planet involves or what it is about. Ladies and gentlemen, with the passage of time, new technologies emerge with the intention of overcoming long-standing challenges, and we know many of those challenges, which make, some of these technologies make work easier. They enable our human lives to be more dignified, and most importantly, they also allow us to do business faster. If all of us could imagine the time we didn't have and now what we are able to transact with just one innovation, M-Pesa, then we know that technologies really do make our work faster. As we also know, as populations rapidly increase in the face of climate change, we have seen emergence of new pests, new diseases, and our agri-food system is actually in jeopardy. And so we need technologies, we need any tool or innovation that would help combat some of these challenges of climate change, which include drought. We have problems of famine. We have the problems of feed systems, and everything seemed to be in disarray. I remember one time, one farmer, I don't know whether he is here, asked a question: for how long am I going to share my sweat with this fall armyworm? You remember the fall armyworm? So he said, if scientists have a solution, I need it now. So, but we also know that even in the human sector, diseases such as malaria, cholera, typhoid, Rift Valley, they all continue to decimate our populations, both human and livestock. And so we need technologies that can help us detect these diseases even before they get to the population. So these problems are also real, and we have witnessed them, and this is where, as ICER AfriCenter and partners here have been feeling that we really need to embrace new technologies, new innovations, so that we can choose between the best of the new and the best of the old to make our planet better. If you recall, our late Professor Calestas Juma, in his book when he wrote Innovations and Its Enemies and Why People Resist New Technologies, he narrated how even a simple innovation like coffee was seriously rejected in Mecca in the 16th century because it was thought to help people to think better because they could stay awake longer, and so they were able to articulate things better after taking coffee. And the kind of information that was passing around was that coffee is like a satanic, is the devil's drink. And even in religious circles, in cultural circles, priests were asking people to stop taking this satanic drink. But it got so popular, and with coffee houses, coffee hubs getting in and encouraging a lot of and some of those social discussions, it was eventually accepted. And it was Pope Clement VIII who said, well, if it's the devil's drink, bring it over, I pray for it so that we can all enjoy it. What am I saying? I talk about this because we have had serious challenges in misinformation and misperception. No other technology that has received the kind of distaste among our population than a mention of genetically modified crops, or what we call GMOs. And just recently, scientists around the world came together 50 years after to find out exactly whether, when they talked about putting up legislative systems to regulate genetically modified organisms, whether they made a mistake or whether they raised an alarm that was actually not there when they look at how much the technology has advanced over time. Recall again, ladies and gentlemen, and our distinguished guests, that in Africa, we now have 9 countries that are cultivating biotech crops, and others are doing trials. We have maize, cotton, soybean, and cowpea that are grown in about 3 million hectares in Africa. Globally, we have close to 90 countries that have planted biotech crops since 1996, over about 2.7 billion hectares. African scientists are focusing on traits and crops and livestock that are of high relevance to Africa. And also falsely accused is the European Union, which is kind of labeled as anti-technology. But may I let you know that the European Union imports over 30 metric tons of commodities every year for their food. And actually, if you did a Google search, although we don't encourage Google searching for some of these technological innovations, if you go there and you'll find that Europe is actually third to USA and China among the leaders in the global biotechnology investments. They have made choices. They have decided that they want to take up this technology for different needs, mainly in the pharmaceutical sector. So the discussions today, we are about to have today, are amongst addressing one of these challenges that clearly are not scientific. I think we have seen that we have more politics in science than we have science in politics, and this is undermining the work of our scientists, eroding trust and faith that our population have on our scientists. So ladies and gentlemen, I just want to mention that here, looking at the whole horizon of human health, animal health, and the ecosystem health, we do have this approach, the One Health approach, that is also helping us understand better how innovations in one sector, for example, an innovation that helps in increasing productivity, reduces encroachment in marginal lands, thus reducing infestation of the contagious diseases such as zoonotic diseases and many others. Reduction of antibiotics is also leading to increased health conditions where we have less and less of antibiotics being used in our livestock sector. The theme of today is growing crops in a healthy planet. I want to remind ourselves that even the World Economic Forum has identified one area or one aspect that is coming in the way of innovations as misinformation. In fact, last year, in the Global Risks Report of 2025, misinformation and disinformation was ranked top among the short to medium-term risks for the second consecutive year, meaning that if you don't handle this problem of misinformation, we'll continue derailing decision-making, reducing the rate at which farmers can access technologies, and so again, we go back to the challenges of food insecurity and becoming recipients of other people's products. So ladies and gentlemen, I know we have our PS here. He came quite early. He challenged us that we really have to respect time, and I want to respect that. But I want to end by saying that as we come together as partners, I want to thank the partners that have seen misinformation and disinformation as a major, major obstacle towards socioeconomic development. And the more we fear technologies, the more we are in a state of inertia, the more we do not act. And so we are very happy that the government has seen it fit to form the State Department for Science, Research and Innovation, because this is just one step where, again, we say, if we continue holding on to our traditional ways of doing things, the risks of doing nothing can outweigh the risk or the potential risks of experimenting with new ideas. So PS, we are really looking forward that we are not going to be held by fear anymore. We are going to get out, and these are some of the champions that are going to get out with us so that we can get the dragon of misinformation handled, that our country and our researchers and scientists can benefit from contributing to societal needs and hence moving our country forward. So with those remarks, I want to end there and again welcome you all to this session and hoping we'll have a very good meeting. Thank you.
Thank you very much indeed. Let's give her a louder round of applause, please, if you don't mind. We can do better than that. It's not easy standing on that podium and addressing people, right?
PS, really, who has just arrived, and congratulations, really, for being our PS, are very one of the finest of men. I do know. The colleagues who have been here coming back from IALA, my colleagues from ministry, from Bio, who have just come, I think they'll introduce themselves. Mine really is a very simple one. Before I say anything, I would like to thank all of you who have come. Wale ambao wamefika kutoka kazi ingine, tafadhali jisikie nyumbani. Tukiongea vibaya, tuambie tuongee, turudie lugha yetu, hata ile ingekuwa ya nyumbani tukaiongea. Lakini kwa sasa muda huu, nijaribu tu kwa Kiingereza kidogo, na yule mnakaa naye kama anaweza translate tu kidogo itakuwa vizuri. Sawa? Asante. My name is, and really, on behalf of the Kenya National Academy of Sciences, and on behalf of National Research Fund, which I chair, let me say this, that this meeting is your meeting. Mr. PS, you have come to really tell us where we have gone wrong, not to have observed, not to have taken up the latest in GMO, where there are some debates. I'm here to thank Isa, Dr. Margaret here, Karembu, for arranging this meeting. You are a great number. Don't think you are about counted, you are about 80 right now. We expected about 100, so they will be trickling in, but the PS has another engagement, and we said, let us just continue. Debate is your meeting. Mine, like I said, we have the World Environment Day being celebrated in Tharaka University. It's a coincidence this week, and you are all invited. Really, rather than me go through a lot of discussions, let me, I think, let's ask my colleagues, Bio, to introduce themselves. He comes in, and I'll introduce our peers very quickly so that he comes in. Dr. comes in.
Yeah, thank you, Professor. Thank you, Prof. So thank you, Professor Atemo Micheka, who was my lecturer at Jomo Kenyatta University of Agriculture and Technology. He taught me wheat and yes. So at National Biosafety Authority, my name's Teacher Nehemiah. At National Biosafety Authority, we regulate GMO, whereby our main vision is to have a nation where genetically modified organisms are safe and beneficial for Kenyans. And our mission is to facilitate safe development, transfer, handling, and use of genetically modified organisms in Kenya. Part of our functions include we consider and make decisions on all GMO applications. We coordinate research and monitor activities of all GMO work as per Biosafety Act 2009. We also manage the Biosafety Clearinghouse, where we share biosafety information and decision made on biosafety matters. We do public awareness and enforce biosafety regulations. We don't work alone. We work with 8 relevant regulatory agencies, including NEMA, KEPHIS, KEPS, and KWS. So so far we have approved PT cotton that was approved in 2020. The PT cotton is a cotton, it is a GMO cotton that was approved. It went through rigorous environmental risk assessment, and the authority gave an approval. So now it is with the farmers. This is the 5th year of planting PT cotton, and we have other products in the pipeline just to assure Kenyans that the NBA is there to ensure safety of all GMO matters. I don't want to take a lot of time. I know where the discussion will be there, and allow me to welcome the ministry official who is representing the PS Rono, Dr. Marango. Welcome, Dr.
I'm too short, eh? This is a bit. Good afternoon. Habari zenu. Prof, thanks so much for teaching me. He was my lecturer those old days, PS, Higher Education, and all other protocols observed. I'm Collins Marango. I'm representing the Principal Secretary, State Department for Agriculture, who could not make it because I'm sure you know that there are a lot of things happening around, because like today, there is a big conference on soil health at one of the hotels in Westlands, and he was making that's what I wanted it to be, a bit higher. I'm telling them that I'm short, but they are not understanding what I'm saying. Yes, open it. Yeah, and then it becomes higher. Yeah, I can use it like that. I think that's better. That's better. So, but myself, I'm Collins Marango. I said at the State Department of Agriculture, I'm the Agriculture Secretary, but I will just read the speech from the peers concerning this very, very important meeting we are having here this afternoon. Distinguished guests, ladies and gentlemen, good afternoon. It is an honor to stand before you today to speak on a topic that holds tremendous importance for the present and the future of our planet, the role of agri-biotech innovation in promoting food security and health themed, harnessing biotechnology for food security and planetary health, addressing national challenges and regional dynamics. I wish to commend ISAAA and all the partners for convening this timely event, which is part of the events leading to the observance of the World Environment Day on June 5th and the World Food Safety Day on the 7th June this year. As many of you are aware, the government of Kenya has laid down bold and transformative goals through Vision 2030, agriculture policy, the agriculture sector transformative and growth strategy, and also in our current bottom-up economic transformative agenda. All these frames, agriculture remains a cornerstone, and we recognize that science, technology, and innovation, particularly modern biotechnology, is central to achieving a resilient, productive, and sustainable agriculture sector. Kenya has made tremendous strides in biotechnology innovation across key sectors such as agriculture, environment, health, industry, and trade. This includes traditional or classical application and other advanced technologies, including modified and genetic modification, popularly known as GMOs. To ensure the safe and responsible use of these technologies, the country has put in place comprehensive legal and institutional framework, including signing and ratification of Cartagena Protocol on Biosafety in 2000 and 2003, respectively, National Biotechnology Development Policy, approved by Cabinet in 2006, Biosafety Act, enacted in 2009, and reform Biosafety Regulation, including Biosafety Contained Use Regulation of 2011. This is for research on GMOs. Then Biosafety and Environmental Release Regulation, that is of 2011. Biosafety Import, Export, Transit Regulation of 2011. And Biosafety Labeling Regulation of 2012 for labeling and the packaging of GMO products for consumer information and the traceability mechanism. The National Biosafety Authority, NBA, continues to play a key regulatory role to safeguard both public and environmental health in the application of modern biotechnologies. I am pleased to highlight some of the achievements in the subsector. One, commercial release of BT cotton in 2020. BT maize, this is resistant to Ebola and genetically modified cassava resistant to cassava brown streak disease and been approved for environmental release. These are at advanced stages of national performance trials and variety release and will soon be available to our farmers. Several other GMO crops and animal vaccine are in different stages of research and development, from laboratory trials to field testing at Kenya leading universities and research institutions. While we recognize the milestone made, we are aware of the limited level of knowledge by the Kenyan public on GMOs, which has led to misinformation and lack of trust to some of these innovations. And that is why I'm pleased today, because of this gathering and the discussion which will follow, because we expect that this one is going to shed some light to our public, and this may lead to more uptake of these GMOs. The misinformation has also triggered numerous litigations in our courts, which has been addressed by our legal team. The government commits to provide adequate resources to undertake mass rollout of public education and awareness, both at the national and the county level, so that people are well informed to make their decisions. By embracing science and innovation, we're addressing valid concerns through transparent, inclusive dialogue. We can make significant strides towards achieving global food security. I commend ISAAA and partners for organizing this crucial dialogue. The State Department for Agriculture fully supports this discussion. We are optimistic that the outcome will not only spark national dialogue, but will also demystify GMOs and related technologies and provide practical policy and implementation guidance to enhance our food systems. Let us continue working together to unlock the full potential of biotechnology for our farmer, our environment, and our shared future. Thank you. God bless you.
Thank you very much indeed. Mona Collins Marango, who's representing Dr. Paul Rono, Principal Secretary, State Department for Agriculture, Ministry of Agriculture, Livestock Development. Professor
Really?
Micheka.
Thank you very much. Give him another clap, please. Really. You know, he says the ministry is with us. What we do is endorsable, it's endorsed. It's really the convincing of the Kenyans that whatever discussions come on GMOs has no effect on our bodies, really. Mine is kind request to our newest peers in the country. In other terms, we say the new boy in town. Sir, could you come and really talk to these people? Give him a clap, Professor Shaukat. He's a long-term colleague of mine for years and years, so rather than take time. Karibu sana bwana.
Thank you very, very much, Professor, who is also the chair and the president of the Kenya National Academy of Science. My friend, Dr. Margaret Karembu, representative of the PS State Department of Agriculture, the CEO of NBA, the CEOs present here, professors, directors, farmers, members of parliament. I had interacted very briefly with members of parliament from IALA, who have also traveled to join this very important gathering. Distinguished participants, ladies and gentlemen, good afternoon. It really gives me immense pleasure and an honor to join you this afternoon on this very important conversation on the agriculture biotechnology. By all standards, this forum is very timely so that you can be able to engage the scientists who are present here, the farmers who are here, and the other sort of leaders who are here to look at a very important subject of food security, national development as well. As Margaret said, it fits very well with growing food and protecting the planet as well. So I think it's a very clear reflection that what is being discussed this afternoon is for something that is very useful to all of us. Friends and colleagues, I'm not new in this space. I have been in this space for a while now. We've been advocating for the use of science, research, technology, and innovation for the social economic development. Many countries were at par with Kenya many years ago. These countries have leapfrogged, yet, in my opinion, we are still walking and we need to run fast. And at this point, I would also want to really acknowledge the efforts that Margaret and Karembu and all partners that are doing by bringing us together so that we can have this very important conversation. Friends, colleagues, the government of Kenya places a very high premium on science, research, and innovation, recognizing the vital role that these play in the social progress, ensuring food security, improving livelihoods, and fostering economic development in the face of the climate change. And a very clear testimony under the leadership of His Excellency William Samoei Ruto. Recently, he established this new State Department of Science, Research, and Innovation, of which I am really honored to lead on your behalf so that we can be able to work very closely together. We would like to focus and have attention on strengthening the country's knowledge base and innovation capacity. This is very important. We should not be just arguing for the sake of it, but we must be able to have facts and figures. And I think this is exactly what we are talking about. Looking at many areas, but just to mention a few, if you look at our lands which are classified as facile, It is appalling to note that 1.8 million people in this region are food insecure, and that almost 500,000 children under the age of 5 and more than 100,000 pregnant women are affected by malnutrition. So that means we must be able to embrace science. We must be able to do more research so that we can be able to address these challenges. I'm a student of change and innovation. I'm a student of the socialization of science. We should not just do science for the sake of it, but how will that science be able to influence policy, and how will the policy be able to influence and improve the society that we live in? We must be able to have more agents of change outside there. And that's why it is very important that we address this matter and effectively confront these pressing challenges. It is imperative that we harness the full potential of science, research, and innovation. From developing climate resilient crops, enhancing early warning system, to deploying smart water management solution and improving nutrition through the bio-fortified foods. And this is a very good example that if you're being faced with challenges of soil salinity, or you're being faced with challenges of very dry areas, you cannot use the conventional method to be able to grow crops. If you are being faced with the challenges of water scarcity, you cannot just use the normal way of doing business. You must be able to do more inventions. You must be able to innovate. You must use technology and science so that we can be able to address the challenges. Colleagues, I like to say that the world is not about to slow down because we are behind. We have to leapfrog to catch up. And the only way to leapfrog to catch up is by embracing science, technology, and innovation, and be able to address the challenges that are affecting our society. As you're all aware, science, technology, and innovation offers practical, scalable tools that can transform how we respond to drought, food insecurity, and malnutrition as well. It is important that we follow this in an ecosystem approach. We must break the silo mentality and build more synergies, more collaboration and cooperation. And I'm glad that institutions are coming together, and I'm going to advocate that more, that we must be able to break the silos and be able to collaborate. We have to bring partners as well. So the public-private partnership is very, very critical. The government cannot do everything alone. So we must be able to bring other partners at the national level, regional and international level as well. It is very important that we also work very closely with the county governments. We at the central government, we want to see that science, technology, and innovation actually goes down, just like the bottom-up economic transformation agenda speaks about, so that we can address the challenges of the livelihoods, we address the challenges of economic aspect, and build resilient countries, so to speak. So, and be able to have it in a sustainable manner. So there is that importance as well. And I want to inform that my office is going to have a conversation with the relevant people and the governors as well, so that in each and every in this country have science, technology, innovation office, and they can be able to have incubation centers and be able to harness the technology that can be able to be built up from the startups. It's very important, in my opinion, that everybody joins this very important endeavor. I would like to acknowledge the development that has been done so far as GMOs is concerned. My brother from State Department of Agriculture has alluded to that. I do not want to repeat. These are very important milestones, and I've always advocated for, when you're looking at GMOs, you can go fiber, you can go feed, and then you can go food. And I think Kenya is in the right direction. You've heard about BT cotton, you've heard about the technology that is being used now in livestock sector, and now also the trials that have been used in maize. It is a high time that at least the staple food in this country should be sufficient for now and the very near future. We should not be agonizing that we do not have enough maize, the food that we love most. We must be able to look at the technology so that every time we are talking about our own staple food, we have enough as well that we are able to grow. Others like cassava that has been mentioned here, which sometimes when you look at the sector, the maize is competing humans and animals, and where cassava can easily, complement the carbohydrate that is being used in animal feed, so that it can be able to leave the maize for the humans as we go along. But the subject of the day, colleagues, scientists, farmers, friends, is the misinformation, the miscommunication, the untruth that is being spoken outside there. So we need to game up. You need to change the strategy. Information is power, and you see that there is fear of unknown. So, Dr. Karembu, this should not be the end here. We must be able to look at all available spaces. If you want to use the X, if you want to use the Facebook, if you want to use the Twitter, LinkedIn, and so on and so forth, we must be able to educate. Sometimes I don't blame the citizenry. I don't blame the population outside there. They don't know. And whatever they know is the misconception and the untruth that is provided to them. So all those in this space, I would like to really to encourage so that we can spread the gospel about the biotechnology, including the GMOs. It is very important. And you've heard that the government is committed to be able to do this. That's why the National Biosafety Authority has been set up clearly to make sure that this sector is regulated, so that we can be able to have safe sort of plants that are safe for humans, animals, and environment. And this is where I am coming from, friends. I've just come back from International Atomic Energy Agency. If you tell anybody about that, you start thinking about nuclear bombs. But the IAEA has been a nuclear watchdog to ensure that nobody misuses the technology, and the technology is used in a safe, secure, and peaceful manner. We need to play the same here, that we should be able to inform the public that this technology that we are advocating for, it is for that purpose. Many years ago, and I want this to go in record, I used to say that Kenyans have got brilliant people. We have trained our sons and daughters. We have the top-notch biotechnologists in this country. For God's sake, let's listen to them as well, because this is not an agenda from outside. This is an agenda that is being built by the scientists in the country. And these scientists have got space as well. So it's very important that we trust and believe in our own as well. And I don't think a Kenyan would be able to misguide other Kenyans so that we can get lost. So it's very important that we continue in this conversation in a very positive way. And if there are any misconceptions, I think it's very important that colleagues, friends are also encouraged to come on board in a dialogue and conversation like this. I want to encourage more frequently asked questions so that they can be responded to, because the population have got the right. They need to know. So information is very, very critical. And so let's continue providing that useful information at all levels. And above all, we might not be able to bring everybody in this room. That's why you're here. By the end of the day, after this conversation and dialogue, if you trust and believe whatever has been said here is positive, is good, please spread outside there. Be the agents of change. And if there are any questions, I am sure colleagues here, the various institutions will be able to respond. It doesn't end here. Today is just a continuation of just what began 2002, 2003, all the way to setting up of National Biosafety Authority around 2008, 2009. The conversation continues. The sciences evolve, and there are so many other things that are going to come. Why should you always be consumers of technology and not producers of technology? Why is it that every time when there is science, technology, and innovation, we keep on asking, is so and so doing it or not? Why can we not be bold enough to take the lead so that we become leaders and not followers every time? This is what I want to advocate, because sometimes we like to watch what other people do and we continue being just followers. We have to also take an opportunity to lead so that people can learn from us. And in this space of science, research, and innovation, I want to assure you, colleagues, that I will do all that it takes so that Kenya can go back to the global map in terms of science, research, and innovation, and we want to lead so that others can be able to learn from us. It's been a wonderful time having these very brief remarks with you, and I wish you all a very fruitful dialogue, conversation, and discussion, and I would like now to officially open this conversation. Thank you very much, and God bless.
Thank you very much indeed. On a PS, Professor Shaukat Abdul-Razak, PhD Department for Science Research and Innovation. Tumpigie makofi tena. Manake amesema atakuwa kipaumbele ku make sure that counties pia zina benefits in a set up centers ambazo zitapush agenda ya biotechnology, right? We now want to go into some discussion, some engagements to break it down the way it's supposed to be done. I don't know if our chief guests are going to be part of this. Ama wanataka kutuwacha. Watangoja kidogo. Asante sana. Kama 10, 15, 20 lisali moja. Asante sana. Dr. Martin Mwirigi ako area. Kabisa. Mtumpigie makofi anapokuja kwenye jukwaa. Anataka kutuvunjia, yani demystify what exactly GMOs are. But before we do that, you know what the problem has always been for the few years that I've interacted with these scientists is that kuna a lot of misinformation na disinformation, right? Wacha tujaribu tu tuone tunakaa namna gani. And don't you worry, nataka ku engage the audience, but don't you worry, hatuko darasani, hakuna marks mtu anapewa hapa, sawa? Lakini tunataka tu kuona how well do we understand GMOs so that tujue wakati tuna address hizi issues shida iko wapi. Na nitafanya randomly, najua kuna wakulima hapa na kuna wajanja wa kitaa, si ndio? For instance, ndugu yangu, what does the G stand for kwa GMO? Usiogope.
Genetically modified.
Nimesema G. Nimesema G peke yake. G inasimamia nini?
Genetically.
Genetically. Na tukisema genetically tunamaanisha nini? Mrembo. Genetically now, in your own understanding, hata kama ni kwa Kiswahili ama Kizungu, genetically inamaanisha nini?
Inamaanisha genome, like
genome.
DNA. Yeah, like DNA.
Like DNA.
Yes.
Technical terms, genome, genetically, DNA.
So, can I say in Swahili?
Sema kwa Kiswahili.
Kwa Kiswahili wanasema chembe chembe za uhai.
Chemi chemi za uhai. Lakini ukiniuliza mimi Gunza kutoka Western, hata chemi chemi sijui ni nini. Sawa, ndugu yangu. Na M ina stand for nini?
Modified.
Na modified inamaanisha nini dadangu? Hauna habari. Hata usitie shaka, uwe ni mjanja. Wewe najua utapata. Hata wewe utapata. Acha niulize huyo mwanasayansi, modified inamaanisha nini?
Inamaanisha kuwa imebadilishwa kiasi.
Imebadilishwa ili iwe bora ama iwe mbovu?
Ili isaidie kuendana na mabadiliko ya hali ya hewa.
Hali ya hewa. Kando na hali ya hewa, nini kingine tunalenga kuchangia wakati tunabadilisha, ndugu yangu? Kuna hali ya hewa, nini kingine?
Crop resistance.
Resistance. Si ndio? Asante sana. And then O ina stand for nini? O, ma'am, what does O stand for GMO?
Organisms.
Organism. Na organisms ni wanyama ama ni mbegu ama ni nini? Living organisms tulisoma kwenye science, right? Organisms ni nini? Ni nini, sister? Organisms. The simplest way you can explain it.
Organisms, I would say, are plants and animals.
Plants and animals. Wanasayansi, are we right? Organisms ni plants, Bwana Dr. Morigi? Almost. Lakini bado, si ndio? Randomly. How many GM or GMO crops do you think are there in the country? Any person, mkono juu, 10,000. Mkisikia pesa mnanyanyua. How many crops do you think zipo ambazo ziko kwenye masoko, maduka yetu, kwenye environment yetu?
I think we currently have 4.
4?
Yeah.
Ambazo tayari watu wana consume?
Sio zote zinakuwa consumed at the moment.
Yeah. Tueleze, ngapi zinakuwa consumed?
I think right now we are consuming cotton.
Cotton?
And then soybean.
Na soybean?
Yeah.
Hapa nchini Kenya?
Yeah.
Any other person with a different opinion? How many crops ama products, mazao ama wanyama pia, manako wamesema ni wanyama na mazao, how many do you think we have zenye zinatumika kwa masoko yetu? Ukienda dukani utapata, ukienda kwenye shamba utapata, watu wanakula, watu wanatumia, watu wanapanda. GMOs.
I can double confirm what he has just said. Because others are on trials.
Ngapi?
On trials we have 3 now.
3 now. How many are in the market commercialized?
Just the best of my understanding, 2.
2.
Yeah.
Which is?
It is BT cotton.
BT cotton.
And soybean.
And soybean. Na BT inamaanisha nini? Biotechnology ama BT? Who wants to try BT? Inamaanisha nini? Hapa tunaongea mambo ya biotechnology. Dr. Murigi na kutayarishia platform.
Nafanya vizuri.
Bacillus thuringiensis.
Hiyo ni nini? What is that? Bacillus
thuringiensis.
What is that?
It's a bacteria.
A bacteria
found in the soil.
In the soil.
Yeah.
So when we have BT cotton inamaanisha cotton
ni kumaanisha kwa mahindi hiyo bakteria imewekwa jini yake katika mahindi ndio iweze kustahimili for armyworms.
Amazing sana. Tumpigie makofi. Your design. So, these are some of the things that are happening. But daktari, nataka utuambie iwapo tumepata that we have 2 products zenye ziko tayari kwa market. Wamesema soy pamoja na cotton. And then you pick it up from there.
Wamepata nusu.
Wamepata nusu.
Taeleza kwa nini.
Tuende kazi. Tumpigie makofi daktari anapokuja kutupeleka na GMO 101. Let's give him a better round of applause. Karibu.
Thank you so much. The moderator. And even for setting the stage. I think that is wonderful because I think I'm starting from a point of knowledge of my audience because the audience seems quite knowledgeable.
Sana wamesoma sana.
So that makes my life easier. So I want to start by appreciating this event, the organizers, ISA, for really being able to bring to us the national dialogue so that we can be able to have a good discussion on this, what you have been talking about, what is GMO? Because a good number of us out there, you'll always hear them talk about GMOs. But sometimes when you listen, actually you are taken aback. I've listened to pastors strongly preach, talk about GMOs, but when you call them and ask them, do you actually understand? Do you know even what GMO is? They start shying away. I've seen politicians shout and everything, but when you go on the side and ask them, do they really understand what GMO is? It becomes complex. So I want just to be able to take us through this topic, basically to be able to understand what GMO is. And I think we all got it right in terms of genetically modified organism. And basically, the organism has been modified. The organisms whose genetic makeup, that is the DNA which we mentioned, has been altered in a way that does not occur naturally. I think that's the main principle. Because using technology, both physics and chemistry, you can be able to alter part of the genome and make sure that whatever has happened can happen actually without doing it naturally. And let me explain how it all began. Historically, what we know is in 1865, we had this monk who you can call a priest of today, although in some parts of this world we still have monks. Even in Christianity, if you go to some parts of Egypt, we still have monks. These are people who have dedicated themselves to stay in the house of God. But during part of it, of their lives, they're also doing research. And Grigol Mendel can be said to them be the father of the modern science in terms of breeding. And this is why before then, before 1865, what we only used to do was basically do collections from the wild and also domesticate. And once we domesticate, we didn't know what to do with it. We only used to do a bit of selection, basically based on what we were seeing. But Mendel was able to explain to us what happens when gametes, zile ziliitwa chembe chembe za uhai, hizo chembe chembe za uhai ambazo tunazielewa, ndio sayansi wanaita nini? Wanaita gametes. Kwa sababu gametes is what we call today, like in human, you have the the cells that are responsible for our reproduction. So you have the sperm and the ova on the other side, isn't it? So what he was able to explain is when you have two plants and they have a trait, let's call it the trait of height. And the first one, we can abbreviate it as T, and the smaller one as small t, just to say that that's the genetic makeup, the attribute. If you combine the two of them, we'll have the child containing the T, the capital, and the small t. So you carry half of your genetic makeup from your mother and half from your father. And what happens is, in the subsequent generation, if the two of those who are carrying these attributes mate, there's a whole mixture of the T, the capital T and the small t. Some of us will carry the two in capital, others will carry the small t and the capital, small t and the capital, and others will carry the small t's. And this is what happens especially at the household level. When you have many children, they will not all look the same. Although the father and the mother remains the same, but the children will tend to look different. And that is what we normally say is what constitutes in terms of segregation, in terms of genetic makeup. So Mendel was able to explain this,
And through this now we were able to do what you call breeding. And part of it, like here, the capital T and the small t, you can call it an hybrid. I believe you have heard about hybrid seeds. The hybrid seeds, when you go where those who are making the hybrid seeds, you'll actually find this kind of crops. You'll find one even you don't want to see. It looks very bad. And another one which looks okay. And this is what is given as seed. And when we say that farmers should not reuse the hybrid seed, it's basically because of this. If you reuse the hybrid seed, what happens? Segregation happens. So you'll have even part of it having the small t's, and this is what causes the reduction in productivity. And therefore, as a farmer, you'll not be encouraged to reuse the hybrid seed, because also you'll end up a part of the farm containing the ones that are not productive. And when you know the economic analysis, you'll find these are a very significant effect in your farm. That is why we encourage the use of hybrid seeds. So the modern biotechnology now comes in, and this one starts in 1953. So in 1953, we had these two people, we call Watson and Crick. They were able to explain. Remember the gametes? We didn't understand the structure of it. But in 1953, these two gentlemen were able to help us understand this structure, which we call the DNA, treated chemically. And therefore, when you understand the genetic makeup, then you can be able to manipulate or modify the way you want. Because now you understand the building block of the DNA, and therefore you can be able to use it. For us who missed a bit of biology in high school, probably I can take you back a bit so that you know where you're coming. Your body is constituted, the main building block is a cell. When you look at your skin, the smallest unit is a cell. Any organ, when you look at your heart, you look at any other organ, is composed of cells. Because the cells are the ones that combine to form a tissue, and the tissues combine to form an organ, and the organ combines to form the organism. And therefore, inside each cell, we normally have the nucleus, and the nucleus is where your DNA is stored. And it is stored in what we normally call the chromosome, which I believe most of us in Form 2 or Form 3 there, they were taken through it. The chromosome, like for humans, we carry 23 from the mother and 23 from the father, isn't it? So the human beings have 46 chromosomes. Each of the chromosome has segments, and that segment is what we call the gene. So when you talk about a gene, normally what you are talking about is a segment of that chromosome, which is now telling us an attribute about you. Because if it is height, it means there's a gene for height. That's why we are not all of the same height. And the gene expresses what you call the protein. In this case, if it is height, it will produce the growth hormone. So this will be the growth hormone, the protein. And it will be expressed until, depending on the structure of the gene, it will be told to stop. You have gone up to the height that is required. If it is your complexion, the same, it is determined by this one. For the ones, like I can use the insulin, because our bodies require insulin to uptake the glucose. What happens is, insulin is a protein. So your body, when you eat, it triggers production of insulin, and the insulin is the one now that will facilitate the intake of glucose, and therefore you'll be a healthy person. So if there is a deformity within the gene, what happens is the protein will not have the right structure, and therefore you'll be diabetic. That is how it happens. The diabetic mellitus and the other one in speeders. So I don't want to go that route, but proteins have their functions. And part of it is like the hormones. Remember this cell? This cell is composed of a structure of proteins and lipids. So your structure is basically being determined by your genetic makeup. I believe now we are okay, so that now we can be able to move to the genetic modification. Can move to the next slide. My team at the back. We need to be at the same speed. So when now we talk about genetic modification, it is guided by these attributes. Remember our protein. Our protein influences productivity, disease resistance, pest resistant, drought, and even the nutritional value. Because it is the protein that commands how the cell will behave. So based on this knowledge, we have four ways of now improving our varieties. One of them is the one I talked about earlier, the one guided by Medel. If you have a susceptible crop, then you can be able to look for another one which is resistant. It can be a wild type, or it can be a variety just within the cropping system. And therefore, if you combine the two, what you'll have is 50-50. You'll have a crop that is carrying resistance a bit, and the other one that is carrying susceptibility. So you'll be at 50-50, but at 50-50, you'll not be able to control probably the disease. So what you do, you use the 50-50 to combine again with the resistant one, and then you'll select the one that has at least 25% susceptibility. So you continue that reducing probably up to 3%. You can see that one takes around 8 to 10 years, and that is what you do in our normal breeding system, even in Calro. When we hear we have produced a new variety, this is what we have ended up with, which started from here. So the variety that you are seeing in the market, when we bring them, it has taken 8, 10 years to bring that variety. The other technique we use is mutation. And mutation here, we are using irradiation. And irradiation can be done, chemical or irradiation, because we know irradiation is able to penetrate the cell and actually interfere with the structure of the DNA. So depending on what you want to achieve, you can be able to do chemical or radiation until you are able to select one that probably is not susceptible. So you keep on doing it and removing the ones that are not having the attribute you want. But now you have what we call the transgenics. These are the ones that we call. It's because when you started here, you have a susceptible crop, but you might not have a relative that is carrying the gene of interest that can help you take care of that susceptibility. So what do? You can be able now to go and look from another organism that carries that gene. Because the genetic makeup, the constitution, remember Watson and Crick, had already shown us the composition. And the composition indicates that the structures are basically the same. If it's a crop, if it's a plant, an animal, a virus, a bacteria, the genetic makeup, the constituents, is made up of the same structure. So you can be able to transfer now that gene from one crop and take it to another, or from another and even unrelated organism like a bacteria. And I think you heard about Bacillus thuringiensis, not the regenesis, the thuringiensis. The bacteria carries a gene of interest that we are interested in. So we can be able to go there and pick the gene of interest and take it to the plant. And that is what we have for the GM maize. So you're able to go through this process. It takes about 8 to 12 years. But recently, and that's where we are, Instead of now going for a foreign gene, we have discovered you can modify the existing genetic makeup without much trouble. Because scientists discovered an enzyme, which we call CRISPR, you can be able now to go inside and fine tune. Because remember, the difference between the elite one and the donor is just a difference in a small genetic makeup. So what you do then, you go straight now to the susceptible and go to the gene of interest and modify it to mimic the one that is resistant. So this is what you do, and it takes around 2 to 5 years. Imagine now the speed at which you are doing things. We have moved from 8 to 10, to 12 years to less than 5 years. This is the technology of today. This is where we are. And actually, this has been applied in so many crops, including health, because recently has been cured of the disease we call the one that your cells cannot be able to take in oxygen. What do you call it? Where you have deformed red blood cells. Sorry? Sickle cell. Yeah, the name was disappearing. So the sickle cell is because basically your gene for generating the red blood cells are deformed, are not in the right structure. So you are able to send this enzyme and go and change the gene and therefore cure the person from sickle cell. So this is already a drug that is already out there in the market and actually even approved by FDA, that is in the US. So this is where we are in terms of technology. And as we are debating on this, scientists already moved to another one because there was too much noise here. Now we are even moving faster. Okay, now to the next slide. Basically, with that context, I just want to mention now briefly what happens in this field. Because the genetic modification, like it was said, from the nuclear energy perspective, you can either make a bomb or you can use it to generate energy, isn't it? So even in this genetic modification, if you are not guided, you can do things that are not right. And therefore, we have several regulations that govern this area. Some are international, like the Cartagena Protocol on Biosafety, to the Convention of Biological Diversity, because we need to be able to manage our diversity in a way that is useful and beneficial to us. Come to Kenya, we have what we call the National Biosafety Authority, and it is guided by Biosafety Act, Cap 320. And also it has 4 regulations, and I think which were quite, briefly highlighted. Can now move faster. So in terms of commercial, because this is a question that was posed to us, which crops do you have out there in Kenya? There are other crops that are commercialized in other countries, but in Kenya, the one that we have already with the farmers is the BT cotton, or what we call the resistant to bollworm. We call it bollgood. And it's because there is this worm, which we call the African bollworm, which eats the ball. Once the ball is coming out for cotton, it feasts on them, and therefore this is what you end up with. Because the balls have been eaten. And this is what the main cause of our to basically collapse. I've listened to so many people talk, politicize, theorize, philosophize, asking ourselves what happened. This is basically what happened. There's no way farmers would have continued growing cotton while this animal is feeding on them. So we have currently this kind of cotton within our farmers, and actually it is transforming the economic aspect of the communities that are now taking up the cotton. The cotton industry is now coming up to where it was. Actually, what most of us might not know is cotton was second to government in terms of employment in the 80s. Most of the economies in the western part of the country and even part of eastern province and the coast was driven by cotton. We had so many ginneries, we had other farms that were making clothes, Rivertex and the others. Then we have BT maize. the one that is resistant to the, the, the maize stalk borer. And this is what happens in your farm when your crops are very young at this height. This animal normally comes, and it's like it comes at night. And basically what happens, it is able to feast on the stalks and sometimes also burrow to your produce. And this is what you'll see in most farms by this stem borer. And now what you have, not only stem borer, we have fall armyworm. The fall armyworm now eats everything. At least this one focuses on the stalk, but the fall armyworm eats everything, the stalk, the produce of your interest. And now we have been able to release this year because NBA approved it in 2022, but this year it was released by the National Variety Release Committee at the Ministry of Agriculture. And therefore, if it was not what is happening in our legal systems, farmers are supporting and planting this season. You are ready to give the farmers, lakini sasa si yetu iko kwa store. So the farmers, what is happening, the insect is still feasting in the field. So we also have cassava, and cassava is a mainstay in terms of those who are coming for a bit of semi-arid areas. And we have this disease, which we call brown streak virus disease. And it normally leads to the rotting of your produce. So a farmer will plant, and when they are going to harvest, that is around almost a year down the road, and when they start pulling out to see the produce, this is what they encounter. You can imagine the tragedy. You planted, here's what you get. And actually, this is what farmers are getting. But we have been able to develop this product. Actually, it's a Kenyan one. Even the scientists who have done it are Kenyan. And there is no other part of the world can say that has this. It's only a product of Kenya. So sometimes when you listen out there and say GMOs are coming from wherever, from north, south, cassava is ours, and the technology is ours, and we have the product that is ours. And basically what it does is, through a modification, you are able to hinder the virus from entering. Because I talked about, you look at, if you have a thief who comes through the window, isn't it? So what do? So you block the window. Basically, that's the same concept. Because now we understand the genetic makeup of the virus and how it enters and causes damage, we basically block that pathway and you end up with a good product. So this product has undergone national performance trial. We are hoping to be able to take it for National Variety Release Committee in the coming months. Then we have genome editing, the one I say where the world is moving. And as if we invested on this technology, you can imagine now we are reducing from 2 to 5 years to achieve what we want. Imagine all these other crops if the government and all the other partners supported us to do this work. We'll be able to take care of much of the work. I mean, the problems we have. We have made lethal necrosis disease. You come and see as if your field has been burned, but it's basically because of a virus. Of gene editing, we are able to edit, and this is the kind of crop you get once you edit, because you're able to block the path the virus is entering. This one, you don't need a foreign gene. You just basically go in there and make your adjustment, and you achieve it. Then you have weed management. We have the striga, the one that causes a lot of harm, especially in Western Kenya. You go to a field and everything is purple. They're not flowers. Those are the weeds. But because we understand the relationship between the crop and the weed, we can be able to genetically modify through genome editing and actually prevent the striga from growing. Because for this striga to germinate, it requires a trigger, a chemical that is produced by sorghum or maize. So there's a relationship, a mutual relationship. So what you do, you go and edit and stop the chemical production, production of that chemical, and therefore, in this field, the striga will not germinate because it's not being triggered to germinate. Just simple and straightforward. Can move on to the next. So in livestock is the same, and I think without much explanation, I believe COVID taught us and made everybody a vaccinologist. Everybody now can talk about vaccines. Everywhere you say, even they say inject or something. But whatever you're injecting is because we have been able to understand these organisms, and therefore we are able to make safer and more efficient vaccines. Because the way the vaccines are made is basically to have the causative agent, the virus or the bacteria, which is made, you expose it to the animal or the human beings like for us, so that you create what you call in immunological memory. That means the memory, your body is made to be excited by something that is mimicking the disease, and therefore becomes ready when the actual causative agent comes in. And therefore that response time is what is very important, and that is how vaccines work. You just create a memory and exposure, through exposure, and therefore you're able to do that. So because of the understanding the genetics, what you're able to do is, if you have a virus that you want to cause the disease, just like the way we have the COVID, you are not immunized by the whole virus. You are only immunized by a component of that virus, because we understand the protein that is responsible for creating immunity. And therefore, by doing that, you're able to eliminate side effects and all other things that come with the baggage of using the whole virus. And therefore, you create a more efficient and more effective vaccine. Also, you are able to modify, just like the crops, you are able to modify animals because the genetic makeup is the same, like I said. And we have diseases which you can be able to modify. There are quite a number. You can either do genetic modification by bringing in a foreign gene, or you can go and modify the existing animal by modifying just a small gene. Like we have a disease we call trypanosomiasis or Nagana. This disease is caused by a trypanosome. Trypanosome is a relative of Plasmodium. They are relatives. So this trypanosome does not cause disease in baboons. And therefore scientists were able to ask themselves, why is baboon not getting sick, but our animals are getting sick? So you go to the genetic makeup and realize the genetic makeup of the cattle, they have the same potential. There's a gene that they have, but it is not active. But the gene is active in the baboon. So what you just do, you go to the cattle and do that modification and make the gene now active. And by doing so, you are able to come up with a trypanotolerant cattle. You can imagine the potential we have. Actually, this country, we have never looked at that disease alone, economic potential, what it does, because trypanosomes do not allow now the farmers to keep good breeds, because we are still maintaining some local breeds with low productivity, and that is because we are trying to get the ones that are a bit resistant. But with this technique, we can free the farmers. They can be able to keep the farmers, grow and keep the animals of interest. We can move on to the next. Yeah, so finally, as I close, I want to read this quotation, which you can go and find. It's part of the WHO statement, because I think we have debated on this thing for a very long time, and people forget there is an authority even in this field. And this is what WHO says. GM foods currently available on the international markets have passed safety assessment and are not likely to present risk for human health. In addition, no effect on human health have been shown as a result of the consumption of such foods by the general population in the countries where they have been approved. That is a statement I don't think we can debate with WHO. They have done the assessment and they have confirmed. Basically, even from my explanation, there is nowhere the risk comes because we are not creating organisms, new organisms. We are only modifying only what is existing. We have another crop which I didn't actually even show, which we have the potato, which we call a GM potato modified to take care of late blight disease. And the late blight disease causes a lot of devastation because the farmers wake up one night and they find as if the field, somebody also was burning them at night. And just to give you the example, because you are familiar, there's a variety called Shangi. That is what when you go to the market, you ask for Shangi. So what we are bringing to you is Shangi. We are not bringing you another variety. Even for the maize, for the cassava, the ones I've talked about, we are not bringing a new variety. We are bringing the variety that the farmers are already growing. It's just that they have been made to have that advantage of taking care of the pests and the diseases. So sometimes I hear people talk as if we are bringing new things. No, they are the same varieties the farmers are growing, and they'll continue growing with no difference, because the only thing that has been changed is for the crop to have that attribute, either disease resistant or pest resistant. Thank you very much.
Thank you very much indeed, Dr. Mwirigi. That was quite insightful. Simefurahia. Meona mali tumekuwa tukimiss, mali tumekuwa tukimisunderstand, and we've also understood where the history came from, like where all these ideas came from. Na tunajua bana, food security is a critical issue, especially in developing nations. Unapata tumeshindwa kukuza chakula cha kutosha kushughulikia mahitaji ya wale ambao ni the population. Okay, right now we want to take it a notch higher by inviting people who've been there, who've done it, farmers who are practicing biotechnology. And apart from that, we will also have experts who are going to break it down for us from a safety issue as well as from the development of this particular GM products. And so as Edna helps us kufanya kitu inaitwa bringing back the seeds, so that we can have Winnie Mobert, who is a farmer from Kitui. Are you here, Winnie? Winnie? Amazing sana. Wapi makofi yo mama. Shupavu. And then we want to have Nancy Odemba. Pia apigiwe makofi ya kilo. Kwa nini ampigi makofi kama mashujaa? Thank you very much indeed. And then we need to have Dr. George Michel. Dr. George, asante sana, makofi kwa daktari, who is the CEO, Africa Genomics Center. Yeah. Please, if you don't mind, let's make our way to the stage so that we can actually have a panel discussion and break it down to our audience today. Johnny kwenye stage, and as they come to the stage, unajua si rahisi kusimama hapa. I want us to do something very remarkable. Let's clap for them until they are seated on stage. Tusichoke, so that tuwapatie motisha, because this is a national dialogue on GMOs in Kenya, and it's not easy. Let's keep clapping. Hata wewe nikikuita hapa mbele utasikia fit sana when people are clapping for you. Let's keep. And as they take to the stage, tunainua sauti ya makofi yetu. Bado hawajafika wote. Wapi makofi ya kina mama? Wanakuja mwendo wa aste aste wakiwa wanasalimiana, au sio? Hao ni wakulima shupavu. Let's keep clapping mazee. It's not easy. Asanteni sana. Hiyo ni computer. Karibuni sana for this discussion. We're going to make it very brief, but ningeomba kusaidiwa na hizi microphones, but I will do it. Kila mmoja ajinyakulie yake. Angalia kama inafanya kazi. Na wakulima pia, badala ya kushika jembe, Leo mnashika kipaza sauti, au sio? Amazing sana. Ananiambia ati anaogopa sana sura zenyu, kizungu inaweza ikapotea, so tumruhusu ongee kwa lugha ambayo haitamchanganya. Daktari Allen, good afternoon. Kwa microphone.
Good afternoon.
Thank you very much indeed. Dr. Mishuki, good afternoon.
And to you?
Aha, Nancy. And then Winnie.
Afternoon.
Sema tena good afternoon.
Good afternoon.
Usemi kwa sauti. Amazing sana. Wacha tuanze na Winnie. We ni mkulima shupavu, labda unatokea sehemu gani hapa nchini na unakuza nini pale mashambani?
Kwa majina ni Winifrida Mubea kutoka Kitui County, Nzambani Sub County, Kitui East. Mi ni mkulima wa Mbiti Cotton kutoka 2020. Ndio nilianza kulima Mbiti Cotton. Mi ndio nilikuwa mkulima. Wale wakulima walikuwa wa kwanza wa Mbiti Cotton. Yeah.
Mkulima wa kwanza wa BT Cotton.
Yeah.
Area ya Kitui.
Yeah.
Na ni nini ilikupatia motisha? Ni nini ilikusukuma mpaka ukaona utaanza ukuzaji wa pamba hapa nchini? Maanake Ukambani najua maembe ndio mnakuza kwa sana. Na hii ingine inaitwa nzuu. Mbona ukamua pamba?
Mi niliamua sababu huko Kitui East mvua ni kidogo. Saa ingine tunapanda mahindi, hatupati kitu. Lakini mambo ya pamba, nilianza kupanda pamba mapema. Lakini wakati nisikia mambo ya MBT na nikasikia vile iko, nikaenda Busia kuona vile ile demo ilikuwa imetengenezwa huko Busia. Nikaona nikirudi acha nilime MBT, na nimekuwa nikilima MBT na nimeona faida sana kuliko wakati nilikuwa nalima ile pamba ya kawaida. Na kutoka 2020 sijalima mahindi juu niliona wacha niwe nikilima pamba. Nikipata pamba napata chakula, nanunua chakula na hiyo pesa ya pamba.
Aha. Na labda utaweza ukatuambia acreage ama kiwango ama size ya shamba lako ni gani, na hapo awali ulikuwa unatoa kiasi gani cha pamba mwanzoni kabla upate pamba ambayo ni ya teknolojia ya kisasa, compared kwa sahii unatoa kiwango kipi cha pamba?
Nalima ya pamba, na wakati nilikuwa nalima ile pamba ya kwanza, ile pamba nilipata nyingi, ilikuwa kilo, na wakati nilianza mara ya kwanza nilipata kilo 1442.
1442.
Yeah.
Na sasa hivi wakati ambapo kila kitu kimeenda shwari unapata
kama mwaka huu ni kama mvua imetuchenga kidogo. Kama hii mvua ya mwezi wa 4 ilinyesha 3 days peke yake kwetu. Sasa mwaka hizi hatutapata pamba vizuri.
Aha.
Lakini hiyo miaka ingine kutoka hapo nyuma tulikuwa tunavuna vizuri.
Amazing sana.
Yeah.
Asante, tumpigie makofi Winnie Mubea, mkulima wa pamba maeneo ya Kitui. And then kuna Nancy Odemba. Unatokea sehemu gani na what's your speciality? Unataka kuongea Kizungu ama Kiswahili? Kiswahili, lugha ya taifa, sio? Twende kazi. Tuambie unafanya kilimo gani na imekuwa ikipeleka namna gani?
Asante sana. Kwa majina naitwa Mary Nancy Odemba. Natoka Busia County. Mimi ni mkulima shupavu wa BT Cotton. Nilianza kulima pamba mwaka wa 2019. 2019 nikalima pamba ya kawaida, zile mbegu za kawaida, nikapata kilo 196. 2020 nikaitwa kwa mkutano kama huu karibu kama huu tu, kiongelea mambo ya BT cotton seeds. Niliposikia hayo maelezo vizuri, iliweza kutembelea shamba ambalo ilikuwa ni ya demo, tukafunzwa jinsi ya kupanda hiyo mbegu. Nikaweza kulima 2020. Nikaweza kulima kwa mara ya kwanza BT cotton. Kilo 596 kwa hekari moja. Kwa sababu sikuweka maanani kabisa na sikuweza kupanda jinsi ilivyotakikana kabisa, maana hata nilikosa baadhi ya vitu zingine. Lakini 2021 nikawa sponsored by ISA. Wakaleta mbegu time. Maana kwetu Busia tunapanda pamba kuanzia mwezi wa 6. Wakanipa mbegu on time. Wakanipa fertilizer. Wakanipa pesticide support hata kwa ukulima wa shamba, land preparation. Niliweza kuweka bidii sana kwa huo ukulima. Niliweza kupata 967 kilograms baada ya kufuata maagizo kamili, baada ya kuwa supported na ISA. Nikafurahia sana ukulima wa pamba ya BT. Hata nikaweza kueleza watu kwamba BT is real. Si ile mambo tunasikia kwamba hii ni kitu ambayo inakuja kutumaliza. Kuua mpaka mifugo, kuua mpaka binadamu. Ikawa kwamba hii mmea ni mmea ambayo unafanya vizuri sana. Hii mbegu inafanya vizuri sana. So from 2021 nimeendelea kupanda BT cotton. Last season Busia we were number 2. I'm also the chair lady for Nambale Farmers Cooperative Union, ambapo tuliweza kutoa, baada ya kupewa BT cotton seeds, tuliweza kupata 96,000 kilograms. Kuonyesha kwamba uzalishaji ama mazao yalikuja juu sana kwa ajili ya hii mbegu ya BT cotton. So kwetu sisi kule Busia hata saa hizi watu wameona faida na umuhimu na uzuri. Hayo mawazo kwamba hii BT cotton, mambo ya GMOs ni mbaya, mambo ya GMOs inaua, mambo ya GMO inaleta magonjwa. Kwa upande wa ukulima BT cotton kwetu sisi imepatia wakulima hasa kabisa wakulima wa pamba nguvu sana. Pamba wanaweza kulima, maana hata imeleta faida mingi kwao.
Asante sana. Makofi pia kwa Nancy. We'll come back to you mtuelezee, manake kule Western watashangaa mbona ulime pamba na watu wanataka chakula, na Ukambani watashangaa mbona pamba na kuna matunda. Tutakuwa come back to the two of you, lakini Daktari Mishuki, siri iko wapi? How is it that they are telling us initially when they were doing kawaida cotton, the yields were low? They actually decided to go the BT way, that profitability has been high, and maybe they haven't been recording as much losses as they used to do previously. Where is the secret?
So the secret of that is in the DNA. So I think what the previous presenter aliongea, I can tumia Kiswahili kwa sababu
which is okay.
naelewa. So DNA kulingana na vile mlielezwa hapa, DNA ni chembe za uhai, na mimi kama expert wa genomics naelewa hiyo DNA yote, na nikikueleza tu kufafanua zaidi kiasi. Kwa mfano binadamu, DNA yake, hizo chembe tunaongea juu yake ni letters, na hizo letters tunaziita kemikali, lakini tunazirepresent na letters. Kama ile Masai beads, unaona ile Masai beads, unatengeneza beads iko blue, red, green na hiyo. So DNA ina 4 peke yake, 4 peke yake.
Na ni leta gani na gani?
A, G and C.
A, J
and
and
C.
kazi.
Kwa binadamu hizo letters unazo 3.7 billion.
Kwa hii mwili yetu?
Kwa kila cell.
Oh, kwa kila cell.
Every cell has 3.7 billion ya hizo letters.
Na tuko na cell kama ngapi hivi?
Mwili wako wote ni cells.
So it's trillions and trillions.
Trillions of that. So it means kwa hiyo DNA hiyo 3.7 billion. Kutoka sehemu ya kwanza hadi ya 10 ina kazi yake. Sehemu ya 10 hadi ya 20 ina kazi yake. So wakati unasikia tunaongea juu ya genetically modified organism, inamaanisha hiyo pamba imeonyesha kwamba hii sehemu ya kutoka sehemu ya 20 hadi 30 ambayo iko na kasoro kufanya huu mdudu avamie pamba. Kwa hivyo hiyo sehemu unaiondoa, unaweka sehemu ambayo haita attract ama haitavutia ule mdudu. Kwa hivyo inamaanisha umemodify hiyo section peke yake, kwa hivyo huyo mdudu hata affect. So yule ambaye anatumia ambao uko na ile sehemu nyingine kwa huyo mdudu, so itabaki sawa.
Lakini inabadilisha the one that you replace, sababu unatoa hiyo section maybe yenye ina attract the si ndio? Hii yenye mna replace nayo inatoka wapi?
So kuna aina mingi, unaweza angalia mmea aina nyingine, mmea mwingine, okay, another plant ambayo haikuwa affected na huyo mdudu. Ukishaangalia una realize hii section ndio actually inasaidia this plant not to be affected. Kwa hivyo unatoa hiyo sehemu unaiweka hapa. Ningetaka kutaja kitu kimoja, ni kama vile mababu zetu walikuwa wanasema kwa jirani ndume yako iko sawa kuliko yangu. Nakuja na kuambia si unisaidie na ndume yako ndio nipate hizo genes za nguvu.
Yes.
So unatumia, lakini ndume hapo ikikuja kwangu isaidie, sijui kama yule mtoto atakuwa amepata hiyo manufaa ama atakuwa amepata. Nitasubiri hadi 2010, maybe miezi 10, 20 ndio niweze kujua yenyewe amepata. Na GMO sasa ni kwa lab. Si tumeshajua huyo ndume wako ni nini yako nayo. Tunahakikisha tumewekea kwenye maabara ndio usije ukapoteza muda wa kungoja miezi 10, 20, lakini lazima tuhakikishe kwamba kile umeingisha ndicho kimeingia. So wakati unasikia research inafanywa miaka 10 kabla hiyo mmea uende, inamaanisha wameangalia na kuona ya kwamba ile sehemu ulibadilisha ndio pekee uliobadilisha. Na hapo ndio maana kwangu mimi husema yenyewe vile KALRO wanafanya, kwa sababu wanajua ni nini tunahitaji hapa Kenya, waweke kile tunahitaji hapa, na ndiposa unaona mimea kama hii ambayo imefanyiwa hapa Kenya na utafiti umefanyiwa hapa Kenya. Hawa ni wanasayansi wetu, ni mandugu zetu, ni madada zetu.
Wasomi.
Yes.
Na iwapo utaelezea kwa kina, umesema tunatoa sehemu moja ya cotton ambayo inakuwa labda affected na pests, alafu tuna replace na yenye iko resistant, tunatoa kwa mmea mwingine. BT cotton ni mmea yupi ambaye alishirikishwa katika kuifanya ikuwe a superior variety?
Swali. So BT ni Bacillus thuringiensis, hiyo ni bacteria. So bacteria pia ni virus, bacteria, kitu chochote kinacho uhai kina hizi letters 4. TAGC peke yake. Kwa hivyo whether ni bacteria, virus and all that, kile kilichotolewa bado kitafit kwa sababu building blocks ni the same. Ama kusema Lego, zile blocks watoto hucheza nazo. Ukinunua Mombasa, mimi ninunue Nairobi, zikiana bado. Kwa hivyo ni kutafuta ile sehemu unataka ndio uingishe kwa.
Lakini kutoka kwa mmea upi? Maanake tunazungumzia pamba.
Unaweza, you see, inamaanisha hizi letters ni the same. Whether ni bacteria, ni virus, nikichukua DNA yako, ni pange tofauti, DNA yako inaweza ikawa mmea. Nikiipanga tofauti yaweza ikawa ng'ombe,
Mhm.
nikiipanga tofauti yaweza ikawa kitu kingine.
We-
Kwa hivyo haijalishi umetoa upande gani, bora tunaweza kukata. In fact maybe mwenye alizungumza mbele yetu hakusema historia. Siku hizi tunaweza kukata DNA na tunaweza kuiunganisha. Inamaanisha nini? Vile unacheza na paper art ama watoto pale CBC wanacheza na makaratasi, wanakata manila paper ya yellow,
Yeah.
anakata ya red, anashikanisha, zinashikana na glue. DNA unaweza kukata kutoka kwa mmea kwa binadamu na ukashikanisha. Kwa mfano, ili ndio uelewe zaidi,
Hata hawaelewi. Mimi naelewa kidogo, hata hawaelewi.
sisi wote hapa I'm sure tunajua mtu ambaye yuko na diabetes. Nimechukua diabetes kwa sababu ilitajwa. Na ukiwa na shida ya diabetes, dawa ni nini? Insulin. Unajua insulin miaka iliyopita ilikuwa inatolewa kutoka wapi?
Tueleze.
Ilikuwa inatolewa kutoka kwa ng'ombe, liver ya ng'ombe ama liver ya nguruwe. Kwa sababu hizo ndio zilikuwa zinaonesha zile chembe chembe zinakaribiana kidogo na binadamu. Kwa hivyo imagine ndio utengeneze chupa moja ya insulin kutoka kwa liver ya ng'ombe, utahitaji ng'ombe ngapi? Ama utengeneze moja kutoka kwa nguruwe, utahitaji nguruwe ngapi? Shida ilikuwa pia kuna side effects because hamko very the same. Secondly, kuna pia Waislamu ambao wanasema siwezi kutumia insulin iliyotoka kwa nguruwe. Now, hiyo gene ambayo inatengeneza insulin kwa binadamu, baada ya wakati ulisikia Human Genome Project imekamilika, ilikuwa inamaanisha tumeweza kupanga hizo chembe 3.7 billion, na tunajua sehemu ambayo insulin inatengenezwa. Hiyo sehemu ilivyo ilikatwa ikawekwa kwenye bakteria. Unajua life cycle ya bakteria within 24 hours imezaana ngapi? So juu iko kwenye bakteria na wengine pia wakajaribu kwenye yeast ile ambayo unatumia kama beki kupika chapati na mandazi, wengine pia wanatumia yeast. So hiyo sehemu inawekwa kwa yeast. Yeast ikisha kuzwa kwa solution kama hii, yeast itaproduce everything lakini haihitaji nini? Insulin. Kwa hivyo ina produce insulin kama waste. Kwa hivyo kwenye hiyo solution we just purify the insulin. Now this insulin is 100% identical na the insulin ambayo inatoka kwa binadamu, but imetengenezwa na bacteria ama yeast. So yeast si binadamu, but imewekwa DNA ya kutoka kwa binadamu, ina produce insulin, na insulin hapo ndipo ikawa bei rahisi, ikawa affordable. So upende usipende ushatumia product ya GMO, ama una mtu ambaye already anaitumia, kwa sababu insulin now is a product of a GMO yeast or a GMO bacteria.
Na hiyo yote ni science.
Hiyo yote ni science.
Guy. Dr. Liavoga, wanasemanga kazi ya Mungu haina makosa, lakini hao wanasayansi wameamua kualter katika ile harakati, wanasema ni kusave life, kama niyo mambo ya insulin ama kuongeza ukuzaji wa chakula nchini. Lakini wengi wanasema katika hii harakati we risk actually messing up with people's lives. True or false? Sasa kama itatolewa kwa nguruwe, iwekwe kwa binadamu na itolewe kwa yeast, na tunajua yeast ni ya kutengeneza mkate na pastries, iwekwe kwa binadamu, are we not altering what is natural, which is what God created? From a scientific point of view, what's your take on that? And how do you separate the facts from the myths?
Thank you, moderator, for the question. So I'm going to answer that question from a food safety point of view. The questions that most Kenyans ask: are GMOs safe or not? My colleague, Dr. Mwirigi, his last slide, that slide basically summarizes what I would say about the safety of GMOs. And from a scientific point of view, the organization that takes a global role in regulating this technology as far as the health of GMOs is concerned. When we consume or animals consume GMOs or products of GMOs, that means crops or livestock, WHO and FAO, Food Agriculture Organization. And they have stated, if there's anything that you leave this place with, remember those two organizations, WHO, FAO. If you ever have doubts about the safety of GMO, go to those web organizations. Those are very credible organizations. So you know, and these are organizations you can trust. You might not trust Alan Liavoga here. You might think he's just talking his own things. But you can trust WHO and FAO. They develop protocols for the past 30 years that all nations have adopted in their laws. And their scientific process in which GMOs and other crops have to go through to ensure that they are as safe as conventional. Dr. Murigi had a slide here that was showing conventional. He talked about mutation, he talked about transgenics, he talked about genome editing. Those are breeding tools that the breeders use to produce whatever crops or to improve our crops or animals so that we get crops that are useful to us, whether it's environmentally or it's for nutritional purposes and so on and so forth. What we need to remember, and this is something that we lose track of, especially the common people, whether it is through conventional breeding, that is through, natural cross pollination, or it is through mutation where they expose this material to chemicals or radiation, or whether it is through using tools of modern biotechnology, what we call GMOs, or whether we are using what he called the new kid on the block, genome technology. Whether you're using any of those technologies, the fact is that they are breeding tools that are used to modify our crops or animals to suit what we need as human beings. And all these tools, whatever tools you use, they have to go through some kind of safety processes that ensure that whatever comes out of that process is as safe as the conventional. Conventional, I mean the tools, breeding tools that are used naturally, through cross pollination. We've tried to advance our technologies in order to solve problems that the natural, conventional breeding processes cannot solve. So GMO or modern biotechnology is not something that is coming out of I don't know where. This is just an advanced tool that is supposed to solve a problem the conventional tools cannot. At the end of it all, the point is that whatever is developed by breeding tools has to be safe. No technology, for goodness sake, is developed to harm. I mean, it doesn't make sense. How can you develop a technology that's supposed to harm human beings or animals? It will not even sell. The fact that modern biotechnology has been there for 30 years and countries are progressively adopting it means that the benefits of this technology far outweigh any risks. But thankfully, if there are any risks that might emanate from any of these technologies, these safety processes that have been developed by these organizations and adopted by our country through National Biosafety Authority are there to safeguard that. So the question of whether GMOs are safe or not, from a scientific point of view, I can confidently tell you that we have safety processes that have ensured that this technology is safe. And thankfully, after 30 years of consuming GMOs, You know, when this technology was started 30 years ago, there were questions. Even those of us who understood the technology, there were still questions. What happens after 10, 20 years? Is there anything that can happen that we don't know of that will make this technology unsafe? Thankfully, now we can confidently say that any risk that is posed by modern technology, that is GMO technology, is equivalent to any risk that can be caused by conventional breeding tools. So from a scientific point of view, there's nothing to fear. But again, from a responsible point of view, we still have to continue applying those safety processes simply because technology is technology.
Thank you very much indeed, Dr. Liavoge. And if, Dr. Mishuki, biotechnology is the way to go, if adaptation of or adoption of GMO is the solution that we all are looking forward to, why is it that it is taking forever for us to actually progress in this area of scientific advancement?
One, I would say it has been about education and the issue of trust. And maybe to just echo what he has said in a different term, a motor vehicle, is it made to be bad? Or an aeroplane, is it made to be bad? An aeroplane is made to be good, but terrorists have used it, or we've had accidents from vehicles. That's why we have regulatory agencies to ensure that when that aeroplane is made, it meets all the requirements. So the aeroplane is not a problem, it's not bad. The issue is usually about motive, and that is where things like NBA comes in to check the motive, because the technology 100% good, and it's being used by our local scientists. Our local scientists are doing it for the good. So the issue is, should a scientist decide to, because it's the same thing, the way you are putting in that good gene, and bad scientists can put a bad gene. And that is where now the NBA comes in, that's where Calro comes in to check that is that. Now the problem has been, people have focused on a person or 1% wrong person having a bad motive. And this has come in from an aspect of even competition and all that. One producer, I want to beat product here, so and so, and so I'm making another product to fight it, and then I claim it is the technology. It's not the technology. That is me who is the problem and not the technology. So I think we need to separate the issue of human evil motive. So the technology is safe, it's good, just the same way. If because that vehicle and use it to rob a bank, do you say the vehicle is bad? No, it's really that particular individual who is the problem. And so to me, I think the reason we have failed to progress is because we have focused on the thief who is using the vehicle wrongly, yet the vehicle is meant for good.
Interesting. And can modern agriculture, that is, coexist with organic agriculture, especially if we want to practice organic agriculture? Or must we do away with old agricultural practices and just go the biotech way? Dr. Liavoga?
Yeah, I mean, there's nothing that stops organic agriculture from existing with agriculture that has used modern technology to create new improved varieties. I think sometimes some of the misinformation we hear is meant to make it appear as if only one can exist, but that's not true. If you are a fan of organic agriculture, that's fine. If you think like our farmers, this GMO technology is useful from your agricultural point of view, nothing stops you from using that. At the end of it all, we all want to get to a place where we have safe food, we have enough of it, and it's accessible. So all these technologies, when they're developed to wipe out another. And one thing we should all remember, GMO will never be the silver bullet. It will never be the panacea of our problems. GMO is just one tool among many tools that are available to try and solve our society problems. There are problems that GMO technology cannot solve. Maybe another technology will be able to solve. All these technology can coexist and should be able to coexist if we follow whatever the scientists and the regulatory agencies guide us to do.
Interesting. Mubea, kule mashambani, Wakamba wanasemaje? Wale ambao wanalima pamba wanasemaje in general?
Wale wanalima pamba huko kwetu wamefurahia, na wakati naongea na wao niliwaambia kuna mbegu ya mahindi tunangojea inaitwa BT maize.
Inaitwa
BT maize.
Twende kazi.
Sasa wanangoja hiyo mahindi. Sasa watu wananisumbua akiniuliza kwani hiyo mahindi itakuja lini? Hata kama kwetu mvua inyesi sana, lakini wakulima wangu wengi wamechimba maji kama mimi, tukingojea BT maize. Yeah.
Kwa hivyo wanafurahia teknolojia
Kabisa.
Nancy, Waluya wanashangaa, unalima pamba na sisi tunapenda ugali.
Asante sana. Bahati Busia ni kwamba mvua iko na sisi huwa tunapanda mahindi first season, alafu pamba inaanza mwezi wa 6 ikiendelea hadi mwezi wa 8. Kwa hivyo kule kwa saa hizi tunapozungumza mahindi iko kwa mashamba, hata ingawa hiyo mahindi ya biti, hiyo mahindi ya GMO ndio na sisi pia bado tunaongoja pale, maana kuna mahindi imetokezea, sijui kama ni hiyo ama ni gani, vile utafiti inavyofanyika. Kuna mahindi inaitwa laini 8, namba 8. Hiyo namba 8 karibu kila mtu ameiangukia. Ukiangalia kila mahindi unaona ni line yake ni 8, exactly 8. So they are wondering, can this be the GMO? Juu hata meno yake ni nono sana na maturity yake ni fupi sana. So kwetu sisi, mimi ninaona kama watu hawana hiyo hofu sana na mambo ya GMO. Ile wanataka tu ni production, kuona kwamba uzalishaji wa huo mmea uko sawa.
Asante sana. Umesikia Dr. Mishuki, kuna disinformation and misinformation, doubts and everything in between. Hii namba 8 laini 8, je, ni GMO? Hii naulizia ndugu zangu Waluya. Manake we need to be sure.
As far as I know, and Dr. Mwerigi will help me here, GMO maize, BT maize, has been approved, but yet has not been released to the farmers. So there is no maize, as far as I know, there is no maize in mashinani that is GMO yet.
But there is laini 8. Dr. Mwerigi, hii laini 8 ni nini? Please, if you may help us. Hii namba 8 ni nini?
Okay. Labda tujaribu kupata aswa, labda wametoa wapi. Unajua uzuri wa wakulima, kitu ikishapelekwa kwao, wanaangalia na wanatengeneza jina yao. So sometimes ile jina ambayo wakulima wanatumia sio ile ambayo tunasema ni variety ambayo tunajua. Hata mimi nimesikia hiyo jina laini 8 mara ya kwanza. lakini kulingana na vile anaelezea mambo ya maturity, kama karo tuka na ile inaitwa ukamezi ambayo unapanda, na kwa sababu inakuwa kwa urahisi haraka, inaweza kufanya ile tunaita drought tolerance. That means hata mvua kama ni kidogo itamachua haraka na utapata mazao. Lakini kwa laini 8 labda nichunguze kidogo, kwa sababu wakulima huwa wanatufurahisha. Hao ndio saa ingine huwa wanatupatia majina ya kuita varieties. Asante.
Asante daktari, kabla urudishe microphone. For purposes of clarity, kuna various varieties za mahindi ambazo sasa hivi ziko kwenye market, lakini haimaanishi necessarily hizo genes zimekuwa modified. Maybe I stand corrected, ama unaweza ka shed more light. Hata kitambo tukigrow up tulikuwa tunasikia katumani na vitu kama vile.
Asante. Mbegu ziko mingi kwa soko na hizo zimetengenezwa. Nakumbuka ile style ya kwanza ama tool ya kwanza amesema, nakumbuka ile niliita classical. Ile ambayo tunafanya conventional breeding, ile ilikuwa inachukua miaka 10 ukijaribu kufanya hiyo breeding mpaka upate ile variety ambayo unahitaji. Hiyo ndio hizo zile ziko kwa market. Ile ingekuwa kwa market ni ile the BT maize. Ile nilikuwa nasema inastahimili ile mdudu ambaye anachimba kwa tunahitaji hiyo stock kwa Kiswahili. Hiyo mkoba mamu kitu. Lakini mnaelewa hiyo stem bora ndio inastahimili. Kwa hivyo tutakupatia ile variety ambayo ziko kwa soko, lakini zitakuwa zinaweza kustahimili huyo mdudu. Kwa hivyo kwa sasa hakuna, lakini tulikuwa tunatarajia hii mwaka wakulima wangefaa kuwa wanapanda. Lakini kuna watu wengine waliona njia ingine wakaenda upande ya judicial system, na tunangoja jaji aamue.
Asante sana Dr. Mwirigi na panelist wetu Winnie Mubea ni asanda. And then kuna Nancy Odemba from Western Kenya, asante. Dr. George Mishuki, thank you very much for shedding more light. Winnie CEO Africa Genomics Center and Consultancy, and Dr. Alan Liavoga, food safety expert. Asanteni sana kwa your contribution. Tuwapigie makofi our experts wetu wanapokaa chini. In not so long a time, we'll be going into question and answer session. Na hii ni nyinyi audience mtakuwa mkiuliza maswali, and Dr. Margaret tutanielezea kama our experts wako area, na nazungumzia kina Nehemiah Ngetich ambaye alikuwa hapa, and then Calro representative Dr. Martin Mwirigi ako hapa, and then kuna Joe Karori, kuna Masila from Kebi, and then from Kebs, Tangari, and then na wengine wengi. We will be getting questions from the audience. But before that, Walter, butulete zile bidhaa ambazo ulikuwa umekuja nazo. And then Dr. Mwiri, if you don't mind, you'll come to the stage one more time. Tuweze kuseparatisha mawili matatu kuhusiana na what's happening in our markets right now. Manake unaendanga supermarket unapata kuna machunga ambayo ni very yellow. Right? Ukikata unapata hakuna mbegu. Unapata unaambiwa GMOs imefika, ati imetoka South Africa. Haya, unaenda unapata kuna mapapai ambayo ni green, yanakaa hajaiva, lakini ukiangalia ndani imeripen already. Unaenda unapata kuna mandizi ambayo ni green na ndani tayari yameiva, na mambo kama hayo. Tunaambiwa there are a lot of GMO products in the market. We will be bringing some of those, and then daktari hapa atasaidia kutuambia kama ni ukweli hizi ni GMOs ama ni porojo tu ya wale ambao hawataki mambo ya teknolojia. In not so long a time. Mziki please. Thank you very much. Asante sana. Na hizi tukimaliza, nani anataka? Hii economy ni hatari sana. Hii ni chakula. Hapa ni karibu 1,000 bila kupoteza wakati. Daktari, tuelezee.
Ule atajibu vizuri ndiye atapata kitu labda.
Utapata kitu?
Ule atajibu.
Ule atajibu. Aya, waulize maswali. Maana naona kuna nyanya, kuna kabeji, kuna sukuma wiki, kuna spinach, kuna maharage. Yameenda wapi maharage? Wapi maharage? Wapi maharage? Ndio hivyo, vyakula aina mbalimbali, na mara kwa mara utaambiwa hii inafura ikipigwa kama hii maharagwe. Unaambiwa hii ukiweka magadi just 30 minutes itakuwa ready. Unaona kuna ndizi kama hizi utaambiwa iko tayari kuliwa, na ukiangalia unaona sikuwa nimekula lunch. Unaona kama hii. Doc, tupeleke na rada. What do we have mbele yetu? Na kuna yoyote hapa ambayo labda genetically imekuwa modified?
Labda kwanza tuanze na wanaitwa audience. Ndio tujue kama kuna mmoja atapata kitu.
Kama atana na kitu nyumbani.
Aseme ile iko modified.
Twende kazi. Waulize maswali. Mimi nitapeana mic.
Sawa. Hapa tuko na ndizi, tuko na kales ama tunaita sukuma wiki, na tuko na tomatoes, tuko na cabbage, beans, na tuko na tomatoes. So kati ya hizo ni gani imekuwa genetically modified?
Nani anataka kujibu? Unataka kujibu? Uende na kitu nyumbani.
I don't think kuna kitu yote iko genetically modified. Yenye tunajua ni BT cotton. Ingine maize bado iko na issues za coat, kwa hivyo bado.
Haya, majibu yatakuja baadaye. Mama, ulikuwa unataka kujaribu? Unaona hiyo nyanya ni kama si ile ya kawaida.
Nilikuwa naona kama hiyo mandizi ni ya tissue culture. Anaweza kuwa modified kidogo.
Na tissue culture
sawa sawa.
Ni GMOs.
Ameleta
another mjadala mwingine.
Haya,
kuna mama pia hapa anataka kujibu.
Inaweza kuwa si GMO lakini ni F1 ile
Guy. Formula 1.
Hybrid.
Oh, hybrid.
Hybrid.
Yes.
Makofi kwa huyu mama. F1.
F1 kama hiyo nyanya.
Nyanya F1. Nani mwingine? Hiyo ni budget utakata.
Naona wamekuwa scientists.
F1
ni first generation.
F1.
Yeah.
First generation. Amazing. Unataka kujaribu? Unaonaje hiyo sukuma wiki?
Haijakuwa modified.
Haizi kawaida?
Kawaida kabisa.
Na dada yetu hapo. Ule. Wewe.
None of them.
None of them has been done what?
None of them are GMOs.
They're just kawaida crops. Amazing. Daktari tu.
Yeah, wamepata. None of them is a GMO. But all of them have been modified in the natural system. Ile sukuma tunaona sio sukuma ya kwanza. Unakumbuka kuna domestication. Kuna historia ya kila huyu mmea. So hakuna ule mmea tunaangalia. Unajua hii sukuma na ile cabbage unajua ni relatives. Hii ni line moja ya breeding.
Fafanua.
Wale walifanya breeding
walianzia hapa, mimi kwa sukuma inatengenezwa, unaenda ukifanya selection. Si unajua sukuma inakuanga na kampira kanaitwa nini?
Ako kampira.
Ako ni kama sasa unachagua zile ziko na ile kubwa. Una select, unafanya breeding na bado na zile kubwa. So utatoka hapa uende ukapate nini? Cabbage. Kwa hivyo hawa ni relatives. Ni vile wamefanyiwa selection ya breeding over a long time. Lakini unaweza kula sukuma unasema utaki cabbage, lakini wote ni
ndugu moja.
na dada. Yes. Na tomatoes unaona hapa, the original tomato in the world ni kadogo sana, hata huwezi kushika, lakini saa hii tuko na kitu ambayo tunaweza kushika, na hiyo ndio inaitwa natural selection. Unakaa ni kama tulipatiwa mfano wa mbegu, si ndio, wa kuomba ndume, si ndio? Kwa nini unaomba ndume? Ukishaomba ndume, ile imezaliwa inakuwa inakaribia nini? Ile ndume. Sasa hiyo ndio unafanya selection. Kwa hivyo hata wakulima ni scientists, ni vile hawafanyi ile mahesabu ya hizo breeding, lakini hata hao wanafanya natural selection, and over many years unapata kitu inakuwa nini? Kubwa. Na hiyo ndio tunapata kwa soko na tunaanza kusema ni GMO. Hapana. GMO, kumbuka tulisema ni mahali utapata kuna kitu unataka kubadilisha na utatoa kwa mmea mwingine ambao wako related, ama kwa mmea kwa kutoka kwa kitu chochote. Inaweza kuwa ni mnyama, inaweza kuwa ni mmea, inaweza kuwa ni bakteria, na iko na ile gene ambayo uko na haja nayo. Ukileta kwa huu mmea kwa sababu ni foreign gene, hiyo ndio tunaita genetically modified. Just to differentiate the conventional breeding na ile tunaita transgenic. Nakumbuka ile niliita transgenic. So tukisema transgenic ndio tunasema ni GMO. Lakini hizi zote ndizi, hizi ni the normal breeding. And some of them like these ones might be hybrid. The tomato. Kwa sababu ukianza kujaribu kutumia hii mbegu kufanya your own breeding, itaenda ikisegregate. Na kusegregate inarudi mahali ilitoka. Kwa hivyo productivity itaenda ikirudi. That is why wakulima wa tomato wanaendanga kununua mbegu. Lakini sasa watu wengi wamekuwa wakitumia hiyo njia kama kutuonyesha sisi wanasayansi ni kama tuna promote watu wengine kupata faida. Hapana. Ni kujaribu ku maintain. Ila tulisema ni F1, the hybrid. Mama ameongea juu ya tissue culture. Tissue culture sio genetic modification. Tissue culture inatusaidia kwa aswa mambo mawili, kwa sababu hiyo technique ya tissue culture venye tunasimia hiyo jina tissue. Tissue ni sehemu ndogo ya mmea. Tulisema tunatoka kwa cells. Unakumbuka? Cells zikikuwa pamoja zinatengeneza tissue. Tissue zikiwa mingi zinatengeneza organ. Na hiyo organ inaweza kuwa the organism. So tunachukua sehemu ndogo sana, kama ni mandizi, tunaenda tutachukua sehemu ndogo ya mkoba, ile part of the stem. Kutoka kwa stem kapisi kamoja, tunaweza kutengeneza 2000 plantlets. Unaona hapo? Kwa hivyo hiyo technique huwa inatusaidia kwa hiyo njia moja ya kuweza kupatia wakulima mbegu kwa wingi. Kwa sababu ukiwa unataka ndizi, hebu niambie sasa, tukifanya conventional ile tunaenda tunakata hizo stems, si ndio? Nikikwambia unipatie 1000, si utakata village mzima. Lakini sasa sisi kwa sababu ya lab huwa tunatengeneza kwa lab, na tuchukue sehemu moja ya stem na tuweze kuimultiply. Kutoka kwa moja tunapata kama plantlets 2000. Kwa hivyo mkulima akikuja hata kupata ugumu wa kupata mbegu ambaye anataka. Akitaka 10,000, akitaka 20,
tunamtengenezea. Njia nyingine hiyo tissue culture husaidia ni kuzuia magonjwa. Kwa njia gani? Wakulima huwa wanapeana hiyo seedling, si ndio? Unaenda unaomba kutoka kwa mwenzako. So unapata saa nyingine mnaenda mnaomba kwa shamba ambayo iko na ugonjwa, alafu unaletwa kwa shamba yako. Lakini tissue culture, kwa sababu kabla itoke kwa mahabara tumeangalia kama iko na ugonjwa, kama iko na kitu chochote ambayo kinaweza kuidhuru, tunakupatia clean planting material. Unaona tofauti? Alafu kitu ya tatu ambayo huwa inasaidia sana, unapatiwa ikiwa ka plantlet ambao kametengeneza mpaka mizizi. Kwa hivyo ukipanda mahali ungengoja upate mazao kwa miezi 12, unapata kwa miezi 9 ama miezi 10 umeanza kupata mazao. So umesave hiyo miezi 2 ama miezi 3. Sio ni faida? Yeah. Kwa hivyo hizo vitu muhimu kutoka kwa tissue culture. Na hiyo technique tuko nayo, ukikuja KALRO unaweza pata many plant varieties ambazo zimetengenezwa na tissue culture.
Na tissue culture si mambo ya GMO.
Hakuna modification hapo. Tunatumia ile sehemu moja tu kutoka kwa huo mmea kuimultiply, na ndio tuweze kupatia farmers enough planting material.
Na Formula 1?
Formula 1
EF1 ya mama alituambia hapa.
Ndio nilisema, unaona kama hii tomato. Kwa Formula 1 sasa ile wanatengeneza hii, utapata kuna male na female ambazo wataweka pamoja. Utapata kwa female, sehemu moja mmea utakuwa ni ule mdhaifu, lakini kuna ule mmea mwingine ambao wataweka ambao uko na mazao mengi. Sasa hiyo ndio inatengeneza mbegu ile tulisema ni T kubwa na T ndogo. Naelewa? Sasa hiyo ndio inakuwa hybrid na hiyo ndio inakuwa na mazao mengi. Lakini venye nirudie, ukitumia hiyo T kubwa na T ndogo kwa mazao mengine ambayo yanafuatilia, itaenda separate ama tunaita segregation. Alafu itarudi kwa T ndogo, T kubwa na zingine zitakuwa na mixture. Unaona tofauti?
Asante sana.
Asante.
Tueleze, kuna yeyote ambaye ana swali kwa expert wetu wa leo? Is there any question from the audience? Is there an area of clarification that you might want addressed? Kwa kifupi, and then Doc ataweza kukaa chini, and then we bring the session to an end. Kindly introduce yourself, what you do, and then pose the question.
Thank you very much, Dr. Mirigi. Very well explained. I think pedestrian, I hope everyone has followed. Just curious about Striga. I did see in one of your slides that there are certain varieties of maize and sorghum that will be resistant to Striga. And I have this problem in my farm. I don't know whether those varieties are currently available in the market or they are yet to be released.
Thank you very much. Any other question? We can take a few and then they will be addressed.
Asante sana. Niko na swala kuhusiana na BT cotton seeds. Vile jinsi nimesema kwamba wakulima wamependa sana hiyo mbegu. Lakini ni nini tutafanya ili tusije tukapoteza hiyo mbegu tena kwa wakulima wetu? Maana hata saa hizi tunaona kwamba ni kama inaanza tena kupotea. Kwa sababu mara wanasema mambo ya bei iko juu sana. Sijui ni mbinu gani, ni mkakati gani imewekwa ili wakulima wa BT waweze kuendelesha hiyo ukulima wao kitumia hiyo mbegu. Asante.
Thank you very much. You want to address those ones, Daktari, and then we take a few more? We do 3. Okay. Your name and then pose the question.
Asante, naitwa Peter Mudhiani. I come from Kwale. Mimi ni cassava seed entrepreneur chini ya organization ya MEDA, but I also do other farming of other crops. My question is on the sentimental part of our farming practices. Wakulima kule Kwale wameimpress hybrid seed varieties, but quite a number of them wanaogopa kuwa zile mbegu zao zitapotea. Na ukiangalia vile mashamba yameendelea kupungua, unapata mtu aliyelima DK 777 hapa na aliyelima kienyeji, baadaye huwezi sema kuwa hii mbegu ni ya kienyeji. So kuna uoga ya kuwa GMOs zikija zikiingia zitapangusa zile mbegu zilikuwa ni zetu za kiasili. What measures are being put in place kuona ya kuwa ile sentimental value yetu ya mbegu zetu za kienyeji zisiangamie inashughulikiwa? Asante.
Hapo sawa daktari. Bado kuna mengine lakini maybe address those three and then we proceed.
Sawa. So nashukuru kwa maswali na ni mazuri. Kuna ya kwanza ambayo tunaulizwa juu ya striga. Iko kwa market ama bado? Jibu ni bado. Hizi bado zinafanyiwa ile inaitwa national performance trial. Kwa hivyo lazima zifanyiwe hiyo research ndio tuweze kupeleka kwa mkulima. Kwa hivyo ziko njiani. Subiri tu kidogo. Na uzuri wa genetic editing, kuna zile mbegu zitapitia National Biosafety Authority na kuna zingine sio lazima. Kama umemodify na hujaweka genes from another organism, kama hizi ambazo tunaongea ya striga, hiyo haina regulations mingi. And kwa sababu hata zinachukua muda mfupi ndio wakulima wapate. Then kuna BT cotton, mambo ya availability of seed. Sijui niombe msamaha kwanza ama ni kwa sababu kuna part probably hatukupata, kuna step hatukupata mzuri probably kama serikali wakati tunaagiza hii mbegu, kwa sababu mwenye kupatiwa contract kutengeneza anatoka India na sengine tunachelewa kupeana order. Unajua wale wana supply dunia mzima, sio Kenya peke yake. Kwa hivyo sengine order ikifanywa late, unapata mkulima hapa Kenya anapoteza kwa sababu inafika kwa wakati ambao sio unafume umenyesha kiasi. Hiyo ni kitu moja. So kuzuia hiyo kampuni sasa imeanza kufunza wakulima wa kufanya local seed production. Kwa hivyo in the near future seed haitakuwa imported, itakuwa inatengenezewa wapi? Hapa. Lakini hata sisi kama Carrot tuko mikakati, tumeandika proposals kwa serikali ndio tuweze kuweka hata hiyo gene kwa variety zile zetu. Ndio sasa hata zile local variety kama unataka kupanda bado iweze kustahimili ile mdudu. Then kuna sentimental value. Na hii sentimental value ya mimea ingine yetu si ya ukweli. Kwa sababu zingine watu wanasema mahindi ni indigenous. Unajua Kenya mahindi sio indigenous. Mahindi imeletwa juzi. Mahindi indigenous iko Mexico. Huko ndio kuna wild variety. Lakini saa hii inapata mpaka hii DK 777 tunaanza kusema ni yetu. Na hii ni DK 777 ni hybrid. Yeah. So vile tunasema tutaleta D777 lakini iko na hiyo gene ya kufanya isikuliwe nini na mdudu. Si ni ule mmea. Kwa hivyo variety, hakuna variety tunapoteza kwa sababu sisi kama wanasayansi tunajua tumesoma mkulima. Na mkulima kuna zile variety huwa anataka. Kwa hivyo sisi hatumletei, hatumbadilishi system yake ya kupanda. Wale walibadilishiwa kidogo ni cotton. Kwa sababu cotton tulikuwa na local variety lakini haikuwa imewekwa genes. Lakini local variety yetu pia production ilikuwa kidogo. Kama mahali unapata kilo 500. Ukipata hybrid inakupatia
almost 1500 tofauti. So ile ya kurudi nyuma tunaenda kwa ule mazao ni mengi. Hiyo ndio kitu moja. So hii DK 777 hizo sentimental value kama Carol pia tunachunga. All the seeds in this country and even East and Central Africa, Carol ndio ina preserve. Hakuna mbegu tumetengeneza hapa Kenya ambaye hatujafanya conservation. Kwa hivyo tuko na institute inaitwa Genetic Resources Research Institute in Carol. Kazi yake ni kuconserve all the seeds, zile ziko na wakulima, zile ziko na scientists, zile ziko hata majirani, nchi jirani wanatumia sisi, kwa sababu sisi ndio tuko na the facility. Nchi mingi Afrika hazina mahali ya ku conserve seed, na ndio kwa sababu sisi kama Kenya tunawasaidia. Kwa hivyo saa ingine mkulima anasema ana preserve ama ana conserve, lakini si ukweli. Mwenye kuconserve ni Carol. Na hiyo ni mandate tumepatiwa na serikali. Sisi ndio tuna conserve, sisi ndio tuna preserve. Na Carol ukikuja unataka mbegu fulani sababu sisi hatufanyi kazi ya kutengeneza faida. Kwa hiyo ambayo imekuwa imetengenezewa hapa Kenya, ukitaka kama mkulima, sisi kazi yetu ni kupatia wakulima ile mbegu wanataka. Kwa hivyo usiwe na shaka, hakuna mbegu itapotea. Asante.
Asante sana, makofi kwa daktari kwa hayo matatu ambayo ameweza kujibu. Kulikuwa na a few more questions. Acha tusikie wanasemaje. Tuanze na ndugu yangu hapa. Wakisha.
Good evening. My name is Joshua from Nairobi City County, Nutrition. Actually, biotechnology has done a crucial role in addressing issues of food insecurity, because one of the factors that is causing malnutrition in Kenya is food insecurity. If we have household food security and national food security, the country will be food secure, and the population and the issue of malnutrition will be addressed. Now, with the issue of disinformation and misinformation, what do you do to bring in other stakeholders like the health departments in addressing this in misinformation and disinformation? Because the issue has been left to us nutritionists. We are the fire extinguishers actually, because at the end of the day, all the consumers are coming to nutritionists. We're being asked whether this food is GMO or is safe for or fit for human consumption. So what do you do to bring in other stakeholders like the health department to ensure that the misinformation and disinformation regarding GMOs and biotech food is demystified? Thank you.
Thank you very much indeed for that. Who else has a question? Ziko nyingi.
Asante, nilikuwa nauliza. Tunaangazia Vision 2030 ambao inatupia kipengele cha no hunger, no poverty, and access to water and food security. Sasa leo tuko hapa kwa sababu ya GMO maize, ndo tujue jinsi ambavyo Kenya yetu haitakuwa na njaa. Serikali nayo koti ndio hiyo imesimamisha maneno. I'm speaking with a farmer voice, sababu no farmer no food. Na Vision 2030 tunataka kila familia iwe na chakula in plenty. Ambia koti ilift hiyo kesi, tupewe begu tupande in the month of October. Number 2, we come from ASO areas na hakuna, mvua ni kidogo, just like you've heard in Kitui walinyeshewa 3 days. Tutapata mahindi na mahindi pia ikose kutupa mazao. Kama watu wa Karo ama serikali yetu ya Kenya, mna mikakati gani sisi wakulima tukipanda hiki chakula tuweze kupata production ndo tukue food secure in the near future? Because we need production for food security.
Thank you very much indeed. Mmeambiwa nyinyi kama wadau muambie serikali watoe hiyo kitu. Sawa. Unatuambia how possible that is.
Good evening. Maybe I need to to talk to the doctors, Dr. Karembu, Dr. Mwirigi, whatever. Politicians and religious leaders are actually spreading this misinformation. I don't know why you, the government, have abdicated your duty and let politicians, people who have absolutely no knowledge of these things. Why can't you experts come here and even call these religious leaders and politicians? I saw some there, but they disappeared, the politicians. I wish you could bring them in such forums. And then number two, that the way you described the coming up with those seeds, GMO, it's like one seed. That long process, it's like you'll produce maybe one or two seeds. So where will you get the capacity to produce, say, when it's a planting season for maize? Does Calro have that capacity to produce such large quantities of seeds? Then I think that's the only thing I have.
Thank you very much indeed. Critical issues there. Why do you leave people who have no knowledge about biotechnology be vocal than you experts? Why? Mtafanya mkutano kama huu wakati mmoja na tutaonana tena next year na politicians watakuwa wakiongea kila wakati. Na hizi mbegu zenye mna produce inachukua 20 juice. By the time imekuwa approved, do you have capacity to supply to areas that actually require these GMO seeds? Any other question before those ones are addressed? And any of you can actually respond to some of those questions or reiterate whatever one of you will have said.
Good evening. My name is Miriam Njeri Murege. I'm a journalist. I write for People Daily newspaper. Just a follow-up to Dr. Murege. You said that we have started production of BT cotton seeds. How far are we as a country?
Your design? Okay, nakuja hapo. Mnaziandika?
Good afternoon. My name is Fatma Omar. I'm an MSc student at JKUAT. So basically, I'm a youth, a Gen Z, let me say. Our main problem is unemployment here in Kenya. Me personally, in my second degree, and we are looking for better opportunities out here. So how will GMO being in the community, in our society, assist us as Gen Zs in terms of curbing unemployment?
Your design. Maybe we address those ones and then we'll take the last lot of questions.
Yeah, thank you. So I will allow Dr. Karembu to answer on misinformation. What are we doing with the nutritionalists and also the politicians and religious leaders? Then we can move from there.
Thank you. And it's good that the National Biosafety Authority is coming on stage. At least they will respond about the court cases and why we can or cannot move. Now, the information challenge, especially from the politicians, and I have a lot of respect for the politicians who joined us here from the East African Legislative Assembly, is one. For the scientific process, it takes years before you can get a product, and you want to make sure whatever product you develop goes through procedures that assure and ensure safety. Now, for a politician, it takes 5 minutes to do a TikTok or to get a big assembly, make a statement in just 5 minutes or less that undoes the work of a scientist that has taken 10 to 15 minutes to do. You undo that, sorry. So what we are requesting our politicians is to give space to the scientists so that in those platforms, those political rallies where you have big populations, when there is a question about safety or about the process of scientific development, then we'll be there to respond. There's something that politicians never do. A politician will never pass a mic to you when they have a podium. Is that true, Mheshimiwa? Anyway, but I think this is a period where we really need to get together and reason. When I hear young people like Fatma talking about challenges of doing or taking up an MSc biotechnology and she cannot get a job, that tells us there is something very wrong about how we are looking at the investments we are making in our young people. Because if there's no need of investing in students, in departments of biotechnology in the region, in the country, I know each and every country within the region has a biotechnology department. But moving the research findings into the market requires policies that support that process of taking a product to the market. But now we are dealing with a situation where there's so much misinformation that has already been passed about this technology that by the time Fatma gets her MSc, it is very difficult for investors to incubate her idea so that it becomes a product. And then we have all these litigations, the court cases that come in the way of an investor who would like to take up our young people's innovations and take them to the market. So a word for the politicians and policymakers, if only we could work together so that in matters of politics, but in matters of science, we reduce the politics because it's a matter of life and death. In some cases, it's a matter of peace and the calmness of a community or our society. Because as long as you have very educated graduates who cannot pass that knowledge to society or get back to the economy, then we will never have peace. So if you want peace, then we also need to invest in policies that also help our young people to drive our economy. They are ready and they're willing. Lastly, there's a question of the seed multiplication. I know I saw the African Seed Traders. A number of companies had come here. And while Calro is doing the research, I know they are also now working with the seed sector so that they are able to multiply the seed. Because the business of Calro mainly is to do the research. Then after that, there are some products or some crops that they still hold custody because of maybe the market is not as big. But in areas where the markets are big, there is the private sector that is waiting to commercialize these products. Thank you. Why the court case? Yeah.
Okay, thank you very much, Dr. Ali. The issue of the court cases, they have been with us since 2022. This is the third year. When those cases were launched in the court, the NBA and the entire government provided a very strong legal team to go and defend the government. And last year, the High Court said the country has a very robust system to regulate GMOs. So and to dismiss the cases that time, that was last year. But immediately after that, the petitioners went back to the Court of Appeal. And the Court of Appeal said, put a break until this matter is heard again. So that's why we are. But most of these cases, if you look at them, it is largely because of misinformation that is with the public. And that misinformation is also across board. We are doing, as NPO, we are doing a lot to educate the public about GMOs so that some of these cases, even the judicial teams, the judges, are able to understand these GMOs. I think you said you want the varieties to come by August. August is just 3 months from now. Government has three arms. There's the executive, you have the cabinet, the ministries, the state corporations, even NBA is there. It's part of the executive. The other arm of government is parliament. Parliament makes law. The other arm is judiciary. Judiciary handles litigations. If you look at the way democracy is created, each entity is independent of what they are doing. So for us as NBA, we have allowed judiciary to make their decision. We have formed very strong legal teams to defend ourselves because we know we have adequate system to regulate GMOs. As someone said, the government cannot release a technology to its public if it is not safe. But for August, it may not be. That would be quite optimistic, maybe, because we are going back to court in July. We don't know how the ruling will be. We'll get a positive ruling will be due in August. Soon, because in terms of approvals, NPS has approved. GMOs also requires that they are also approved by NEMA. NEMA has approved it. KEFIS has a role to approve these GM crops. They have also approved. So it is only that the court have said, let us put a break a little. I think once the court issues are addressed, the seats should be able to be coming to you quite soon.
Yeah, thank you. Our colleague from NBA, Mr. Mushiri. I think, Professor, you can help us answer unemployment. The Gen Zs are looking at the GM environment. Is there potential for employment?
Thank you very much. My name is Vase Mwaja from Kenya National Academy of Sciences. I happen to be in this space the last 35 years. One aspect that has been lingering is asking ourselves, are we questioning the technology or the product of technology? We are now sorting out the product of technology called the GM corn, GM soybean, GM cotton. Once that has been accepted, we know there are no issues pertaining to the technology itself. Remember, biotechnology is a tool to enhance or to fast track. Moment we come out of that handle, the private sector will be attracted. I want you to understand, underscore that. Private sector is the main source of employment, whether we like it or not. Because the private sector will take over the aspects of producing that technology will now be used to generate the products of biotech. So which means that companies will specialize in each one of those components and will develop the framework in which to expand and increase the productivity of those, whether seed, whether other products. So your job will be, because people will be interested in utilizing your talent in biotech. That's one space we're looking at. So when GMO, we kind of get carried away by the word genetically modified. We forget that use of that technology has enhanced or has increased. I've got a case study. When I was a young person doing my postdoctoral research fellow, I was working on about genetically modified corn and soybean. And at that moment, early 1990s, is when we had just released the first set in the US. And it took us about 2-3 years to educate not only the policymakers, but also the farmers are always ready to utilize tools when they come to them. I was telling Margaret, decarb maize, I worked on it in 1990, 1991. And that DK is called decarb. It's a company, seed company, which is based in Chicago. And when biotech came in and Monsanto came in, the GM corn and soybean, there was scramble for seed companies. And the chemical companies bought out all the seed companies globally. The whole purpose was one. Because the technology, they were pushing the technology through seed. So seed becomes the carrier of technology. It's a long story. To cut it short, yes, there's a high potential, I can tell you that. There's a high potential for young men and women to open avenues when we cut that chase now. At the African Union, I happen to be the vice chair of African Scientific Research Innovation Council. The African Union is also promoting biotechnology is one of our flagship projects as enhance biotech in the continent so that we can create more companies that can go to the grassroots where we are. It will be very nice for you to open your own biotech component in, but you're sorting out the issues of the farmers within Busia environment, Western Kenya. It will be great wherever you are, you have what we call an environment where there are problems, and the use of biotechnology now, that's what we are talking about. You can be able to sort it out. So basically, yes, I would say that. And I'm optimistic personally because knowledge today, but when we were starting off, we thought it was a long shot, but I think there's a way out there. I will also pick about the seed multiplication. Seed bulking is a process. When the researchers of the Kenya Agricultural Livestock Research Organization produce a germplasm or that particular improved seed, it needs to go to the next phase where it must be multiplied. And that's why institutions like Kenya Plant Health Inspectorate Service, which is supposed to be looking the trials, looking at the performance trials for that seed, they are able to work with the seed bulkers, seed companies. Let me add, unfortunately, and I use the word unfortunately, we took away these areas where we could produce the seed. And that's why we have become seed beggars. I could use the word beggars because Ethiopia's got more space. So multinational seed companies will go where they can get huge tracts of land where they can grow seed so that it's not contaminated. So it can't come, I'm talking about like maize seed. It requires a lot of space. And you need that area you live as free so that the pollen doesn't move from one region to the other. So what we are saying, unless we continue now doing contained production, like what we're doing now, when we went to Kiboko, when we're talking about a breeding of looking at corn, we are growing it in Kiboko. We are not growing it in Kitale because we are afraid that the seed, the pollen will be running all over. So basically we are saying, yes, it can be done, but, I use the word but, we may have to cross over to our neighbors may have more space. Ndugu yangu kutoka Tanzania, we know very well they got more space. Tukienda kutoka Morogoro mpaka naenda Dodoma, I can see a seed production region. So let's call a spade a spade. As an African Union component, we are saying we want to encourage the countries to work together so that we can be able to stop this bringing of seed from Asia or from Americas. So it's doable, and for the youth, I can see yes. The next aspect too, on biotechnology and other aspects, we are going to other technologies, agri-technologies. Today, we are talking about robotics. Robotics is going to be part and parcel of the process of biotech because it is what we are using now to transfer those particular genes. It's becoming an interest part. Don't lose hope. There's still light at the end of the tunnel. Thank you.
Thank you. Let me just do a bit of addition on what my colleagues have said. Just to add on the nutritionist question, I think ISA and OFAB has been doing a good job also engaging the nutritionalists and the religious leaders. Actually, the last time we had an OFAB engagement where we had so many religious leaders from different counties. And basically, as you speak today, a good number of religious leaders are now listening to what we are saying. Actually, I remember talking to one and he was asking me now, what do we go and tell the parliament? So that, because now they have understood, actually the push was for me asking, I tell them what they should go and say on our behalf. So I think the environment is changing and we really appreciate. Then there was a question of Vision 2030, and I think I love Our Lady, because our development should be anchored on a vision, on documentation. But interestingly, I think since we are parliamentarians here, the Vision 2030 describes biotechnology as an enabler. But I can tell you, since it was formed, we have never had biotechnology in our medium-term plan. I don't know if it's deliberate, if somebody actually, because the way the government works, you have the vision, then you have the medium-term plans, which now set the stage on what needs to be funded, what needs to be enhanced, but we haven't. So it remains in the document, biotechnology as an enabler. So as a country, we are very good at writing, but implementing is chaotic. So it has to do a retrogressive, thinking.
Do we really need even right to think, to write? Because if we write and we can't follow, can't play the script, then it's not worth it. We spend a lot of money writing that document, and we start writing another one, probably Vision 20 something. And we spend a lot of money, but we are not playing by the script. Is Caro able to help us become food insecure? The answer is yes. Because for us as Caro, we are giving you the best varieties we can. And that is the essence. Good farming requires good variety, good understanding of the soil. And Caro, that is our strength. We are the people doing the mapping, soil testing, ensuring that you plant the crop in the right way, teaching you on the techniques for farming. So Caro has everything. So for us as a country to become food secure, my own would be more of a personal hypothesis, because other countries have done it. It has to decide which are our priority crops, and then move in and do what is necessary. We already know the crops that gives good production with less input. India, China, they're feeding themselves. I don't want to mention the crops because you will think I'm favoring them. No, the truth is those countries are in billion. They are more than 1 billion, but they're able to feed themselves because they have prioritized the specific crops which they know. The others needs to be just luxury, but a country has to feed. Protein production, access to protein. We know the best animals to give us the best foods, in terms of production. We know the ones that have what we call food conversion ratio that is very high. You feed small amount but get a large amount of protein. It's about us now selecting and deciding on what to do. So probably this calls for another national dialogue where we are not discussing to ourselves, but as a country and decide what do we do for food security to come. But in terms of Caro, we have what it takes in terms of giving you the best advisory, the best varieties, and helping you even at the farm level. Then the last one, probably as we proceed, there was a question about the seed, and I think it was a bit scientific because he was asking, since you will start with one seed, how will you be able to multiply? In that system, I didn't have time to really expound, but it's at the beginning, it passes through a tissue culture system. Remember I explained about the tissue culture? From one coli, or what we normally call the colors, within the lab, you can be able to come up with 2,000, 3,000 because of using the tissue culture for initial multiplication. Then from there, once you have done it is a crop like maize, now you can do the conventional breeding as it was explained by Professor. Then lastly, in terms of Gen Z's thinking about employment, I think in my presentation I talked about cotton and how it influenced employment. And I said it was second to government. In the sense, when you look at the value chain of that crop, there is employment at the farm level. There is employment at the transportation. There is employment at the ginnery, which we closed, but now we are opening them up. Once you get to the ginnery, you'll have 3 pathways. There is the fiber. That means Rivertex, Kikomi, all this. And actually the other day we were in Mwea, we have already started seeing cottage industry. Go here in Mwea, you will get materials which have been produced from the BT cotton employment. Then it will give you also cotton seed. The cotton seed cake is used for animal seed, feed production. That's another line of employment. Then the oil that is gotten from it. So it goes to the industry to make oil. So you can see from that crop alone, as a country, if we got it right, just one crop, Gen Zs will not go on the road. I can assure you. The jobs will be enormous. And I'm talking about one crop. If we go to cassava and think of the value chain of cassava, it is endless, including producing ethanol, producing so many things. It's just for us, we are seeing cassava as food, but it has industrial use. All the medicine that you are seeing, the capsules, where do you think they are making the capsules from? It is for us as a country just to think, just one step, and I'm sure Gen Zs will live to be happy people. Thank you.
Thank you very much indeed. Very briefly, we had a question here. And then any other hand up? Guy. Okay. Maybe make those questions very brief so that we can try and wrap up because we're running out of time. Your name and then you pose your question.
Yeah, my name is Wanjiro Kamau. I'm an organic farmer. Thank you for the national dialogue. The one of the questions I want to ask, as we think about commercialization of BT maize, we find countries like Mexico, and they had commercialized maize. They are now banning maize and going back to their indigenous seed varieties, whereas we are thinking of commercializing. So we need to think, is this the right way to go before we move in there? Because the countries that were ahead of us are now going back to what they were doing. Number two, I'm very curious now that we have grown BT cotton for more than a year, maybe 2 years since it was commercialized. I think it was 2019. What are you finding, because you are required as per the Cartagena Protocol, what are you finding of the social outcomes? What are you finding about the environmental impacts of growing BT cotton in the areas that is being commercialized? The Cartagena Protocol also requires that we separate GM products from non-GM products. What is happening to the oil that is coming from the BT cotton? Is it being separated and labeled in the market? And the cotton that's not BT, is it being segregated at processing? So do we have those structures in place, or we are just propagating this agenda without the proper institutional safety mechanisms that are required of us as a country to the protocols that we have assented to? Thank you.
Thank you very much indeed. That's an organic with very, very critical questions. Where was the other question?
Okay, my name is Richard Mausi, a journalist from The Nation, Daily Nation. And I have only one question. Initially, you talked about seed bulking. And my question was, you talked about some farmer groups being trained on how to multiply seeds. And maybe from my take, don't you think that is a very dangerous affair in such a country because of instances like counterfeit seeds? Then my question now is, what does it take for one to venture into seed multiplication?
Amazing. Another one here.
Yes, my name is Calvin Sodero from the Kenya Plant Health Inspectorate Service. So I would like to, it's not a question. Yeah, I would like to first answer the farmer who was talking about number nane. That number nane is a real variety that is being commercialized by the Kenya Seed. And it's a variety that is commercialized in Busia and Kakamega. So that is a variety that exists. And it is not GMO. So when Daktari put all those varieties there, I was even afraid that one person would say that the tomato that is there, that is really big, is a GMO. And I would like to say that that is not GMO. As KEFIS, we do regulate release of crop varieties into the market. When Dr. was talking about the National Variety Release Committee, and he was also talking about the NPTs, that is what KEFIS does to ensure that whatever reaches the farmer in terms of value addition. So when Dr. is doing all that research to come up with a variety that is resistant to a particular disease, then we have to ensure that this variety at the end it is tested, and we have a variety that's able to perform or meet the purpose that was also talked to. So that is what KEFIS does. There is a question that he asked.
Yeah.
Yeah.
Seed multiplication.
About? Can you ask it again? I wanted to say something about it. Oh, yes, I remember.
What does it?
Yeah, about the grower, eh? So KEFIS ensures that all the growers in the country are registered anywhere and become a seed grower. So we do register seeds, and when we register you, we regulate how you do the seed multiplication. So the seed companies usually liaise. We have the seed companies liaising with the seed growers who can be the private sector, maybe an individual farmer or a company who is there to grow the seeds. So as a grower, you come to us and then we will register you, and then you link yourself to a seed company, whether it is Kenya Seed, whether it is Western Seed, or which seed company. So you are contracted by that seed company to produce for them the seed. So then we will be able to curb the essence of us having very many people producing seeds. That's your worry, so that we have several fake seeds in the market. I think you answered.
We can answer.
Want to address those ones, and then we continue?
Okay, probably we can start with Mr. Mushiri on the aspect of social outcome and environmental impact of the BT cotton. I know you did the assessment recently.
Okay, thank you very much, Wajiro Kamau. I think, yes, the BT cotton was commercialized here in 2020. So we are almost like in the fourth cycle of production. But that cotton, when you look at the history of other countries, it is a crop that has been cultivated for more than 15 years in other countries. I think in terms of the social impact, earlier in the session we had farmers here, and what I listened to them saying, before the introduction of BT cotton, the farmers were harvesting roughly about 500 kilos per acre. What I heard them saying, with the introduction of BT cotton, they're able to produce or to enhance that production to around 1,400 to 1,500 kilos per acre. I think that alone has a very positive impact on the livelihood of the communities. And alongside what Dr. Muligi was saying, along the value chain, if you have more production at the farm level, ultimately at the transport, the ginning, at the textile industry, we expect more positive impact along the entire value chain. From where we sit as NBA, because it's our mandate to monitor any commercialized GM crop for 20 years. We are still monitoring this BT cotton, and we will continue monitoring it until 2040, because we are required to monitor for 20 years. It was approved in 2020. We will continue monitoring it until 2040. So far, you have not seen or you have not received any feedback from the farmers, or do our inspectors found any health or environmental impact of the BT cotton, as it were. But we will continue monitoring. So far, we have not found any adverse effect. If you find any, I think we'll come to the public and inform the public that we are investigating this. But so far, we have not found any adverse effect. You mentioned Mexico is banning maize. I think earlier Dr. Muligi said Kenya, we do not have wild relatives of maize. All the maize that is being cultivated all over the world originally came from Mexico. That's why you have found it's called the teosinte. That's why the original maize is. And I think the Mexican government has said since the country as Mexico hold that privilege of having the indigenous maize varieties, I think they have said for cultivation, I think they have put a pause, but I think for consumption is still going on. I think, but for cultivation, because of that historical and maybe the need to preserve the original maize varieties, have made that decision to pause the cultivation of maize. But consumption is going on, either for human and also for animal feed. So as you know, at the NBA, we also have for those farmers or for those consumers who would wish to consume maybe organic, but there are also those that are also requesting for these technologies. There are farmers who say, bring these technologies to us, so long as you have assured they are safe. So you have a labeling system that ensures those farmers that want to access the GM seeds are able to access it. And for those who would wish to continue the organic or the conventional maize varieties, those varieties will still be available in the agrovets. So those systems are there. Those farmers who are saying, I want the GM technology, that technology will be labeled. It's being labeled. For those who want to continue with the conventional organic systems, the seeds will be labeled as is. But for the BT and other GM crops, we have already developed a label so that as you go to the shops, farmers and consumers are able to clearly distinguish the GM and the non-GM varieties.
Yeah, thank you so much, Manu Moshiri. I think what I can mention is social impact is quite wide. And sometimes scientists cannot be blamed for everything. Because if you become rich, what you do with the richness is not our responsibility. You can build a house, or you can marry as many wives as you want. All those are social impacts. You can even become a drunkard because you have money. So we have limits in terms of social impact unless there is something that we introduce and actually has a negative impact that we can see. And that is part of the responsibility. I think what he forgot to say is when doing assessment, the product that we present to NBA, they have a socioeconomic component where they actually send to socioeconomists to do an assessment to see the value of whatever we are bringing to the market. And actually there is one crop which was declined by NBA, called what? Gypsophila, the flower, because the market was in Europe, but Europe did not have procedures for receiving it. Since we did not want to destabilize the country, basically on that basis, NBA declined to give commercialization license. So there is consideration even to that level. Then about products and how do we label them? I think it is fair. It is not fair to say the country does not have structures. Because the truth is, this country has structures, even for labeling. There is a whole standard that is responsible, that will ensure that labeling is done. What probably the moderator didn't have time to introduce, I also chair the Biotechnology Technical Committee at the Kenya Bureau of Standards. And that is one of the standards that we produced. Although we have a general labeling standard for general product, we deliberately developed one for GM crops, products, just to give you comfort and choice. It's not a matter of safety, but it's a constitutional right to choose. But interestingly, 80% of cotton globally is cotton. We are all seated here. How many are wearing clothes that are local? 80% of us seated here are wearing GM cotton, including the person who asked the question. In the wardrobe she has, 80% of the cotton will be GM. So sometimes let us not create a fallacy. Let us look things in reality and not bring a complexity where there is no complexity. So labeling will be there, and labeling will be as per also the normal expectations for labeling. Today, if you make mala yogurt, you can sell to their neighborhood, isn't it? Cabs will never come for you because the source is known, isn't it? We can trace. But if you decide to take that yogurt and put it in a shelf in a marketplace, cabs will be on your case because we want to be able to do what we call traceability. So some of these things are not a matter of safety. It's a matter of choice and sometimes just being able to carry traceability aspect. So, and also when it comes to follow-ups, you can only follow to the level where you can detect oil made from any product, not a material. Remember this,
The nucleus is the one that is containing the genetic makeup. So, but when you press that seed, what comes out is oil. And how do you quantify in the market? How do you test for oil that is GM, the other one is not? Yeah. So there is a level of practicability even when you go to the market. So the issue would be the oil that is there is similar to the one that is from the conventional crop. And that is what NBA does. When we make our presentation, when we send our document for approval, we must prove that the product that is we are changing, nothing else in it changes. If it is oil, the chemical component from the natural existing and from the GM remains the same. Are we together? So, and that is how we do science. It has a limit also, but also we ensure that the chemical component for the natural one, I mean conventionally bred or indigenous if you can call it, and the GM, they are all chemically the same. Then I think the question of using farmer groups as being dangerous is not true. Actually, in this country, most of the seed is produced by farmers. That's the truth. It's just that we have KEFIS who has developed the guidelines, and it is the guideline that is followed. So with rigorous inspection and testing of the material before they go to the market, so that you ensure that whatever the farmer was supposed to produce is what actually is packed. And that is the responsibility of KEFIS, and they do it so diligently, including nowadays they have a code for actually confirming the counterfeit. Remember you said there will be counterfeit. There is no counterfeit because when you buy that seed, the packet has somewhere where you scrub, and actually you can set that code and it confirms to you if it is genuine or not. Otherwise, somebody using another method of seed production is not producing seed. It's actually your food, just that you converted it into food, into seed. Actually, even at the farm level, by the act that regulates seed, if you use the next generation, remember the one I was saying you reuse? That is not taken as seed. Because by definition, the seed must have been certified. And there's a process for certifying seed. So you cannot just come up and say you are producing seed in this country. We will put you into jail. It doesn't matter if it is GM or the conventional. You cannot claim that you are producing seed unless you are a registered seed vendor and you have the license. So probably with that, you can add something, Professor and Dr. Margaret. Go ahead.
Okay, I know we are really running out of time, but there's one thing that this national dialogue should also come up with or clarify, that biotechnology is not a system of farming. And so when you talk about farmers going back or countries going back to their original farming, it's about looking at which tools fit best within the problems or the challenges you have for the agricultural sector. And so there are regions in this country that would be very favorable for what you call organic farming or agroecology, which is now a system of farming. But agroecology is enriched by using the best tools in the market that help reduce the amount of chemical pesticides you apply to your crop. That is all what agroecology is about, that you are reducing the amount of external inputs you use to grow your crops. And so when you think about an ordinary farmer having to share his or her sweat with pests and diseases, that scientists have come up with a tool or a solution that can help that farmer, then it would also be unfair to tell farmers or prescribe to them that you can only have this form of farming, but don't use this tool and that tool. So it's very important that we clarify here that biotechnology is not a system, is just a process that comes up with tools that expand the farmer's toolbox so that the farmer, him or herself, can choose which tool best suits for her condition or for his challenge or problem. I think this is very important because I've had a lot of discussions, why don't we go back to tradition? Everybody, we are more comfortable in challenge the status quo. But now this is that we call them disruptive technologies because they challenge the way we have done things over time. And look at our yield per acre of any crop here, compare that with the global average. You'll always find that Africa still lags behind anyone else. And one of the common factors that has improved productivity and yield for farmers is when you protect their yield from being chewed by pests and diseases. It's not even magic. It's really just looking at, and it doesn't have to be biotechnology, by the way. It's these tools that help safeguard the farmer's crop and yield or livestock so that the farmer is able to get better yield. And by getting better yield, then you're removing that farmer from being a subsistence. In fact, I find using the word subsistence to describe farmers or peasant farmers derogatory, excuse me, because farmers, every farmer here and farmers who are here, they're always looking out for ways of getting out of that sub living to get into the market. And so if science is providing tools that can elevate or move that farmer from being a subsistence or being a peasant to a farmer in the global space who can also produce products that are favorable for the market, this is what we should be talking about. But of course, it has to be safe, it has to be ethically applied, and also it has to fit within our socioeconomic setups.
I don't want to overdo on this one. Next stage, we are going to biofortification of foods. We are now saying through biotechnology, we are getting tools to help us control pest diseases and weeds. But then we are now on another stage of improving that food, that maize. We want to improve it a little bit and have a bit more protein in it. Because what is going to happen, what makes it better than having ugali, where you know it's not only a carbohydrate, there's some other elements within that particular food. And through the same technology, the same I said, are we regulating the technology of the product of the technology itself? So the next stop, whether we like it or not, is biofortification. And this is where we are now. This is the stage where the global world is increasing the value in terms of nutritional value for that food. Next stage is looking at business. Farming is not a way of life, no longer. And we have these our young men and women, these Gen Zs, they are looking, can I have my livelihood through farming? It is only feasible to do that by introducing technology that can enhance the productivity. One of the challenges the continent has is what we call, as Margaret just alluded to that, our productivity per unit area is very low. So we remain food deficient forever until we improve that so that we can increase the level of production, so that it in line with our population growth. Otherwise, we'll become food deficient forever. So, ladies and gentlemen, I think time has come to know, as we move forward, as we question technology, like we question fast cars, people drive them, and nobody questions that. That's still technology. We are saying, can we improve our agricultural production? Can we improve our agricultural activities so that the farmer can benefit from farming? That's the question we have. And for the sake of my good friends from the other side, the political class, this is the best friend. They are communicators because they are the people working with the communities. And we're saying, for us as scientists, we go to develop, and I'm very happy, Margaret, for this forum today. We got to have many more of these talks. Maybe this is the point where we have started. We're going to cascade it further and make it a little bit segmented and focused so that when we come, we can deliberate on an issue and work around it and say, what do we see from here? And I think the next one I'm going to do is biofortification of foods, because it brings forth again, elevating this food from production to quality production so that the people can benefit from it. So I think it's a challenge we have. You are not alone. And I want Kenyans to listen to this. We are not alone. People have walked and we're still sitting down. People are running and we are walking. Nobody is going to come and tell you, can you increase or improve your production so that you can come to the East Common Market? Nobody will tell you that. It is for you as a country to go back to the default and say, what did the Vision 2030 envisage? Some of us happen to have been there when the Vision 2030 was being crafted. We were part of the group that crafted it. We are looking at improving the productivity of the African farmers so that we stop begging from anywhere. And if we can do that, then we can sort out a lot of problems. Number two, we are complaining of employment. You can only employ if you increase the activities, because you've got more getting to the market and people are getting different avenues. This morning, a few of you had conflicts. How many of you had conflicts if you didn't? Or those who travel, like my brother, I saw it in the hotel, or those who travel. Every one of you enjoys that bowl of conflict. You're all feeding on genetically modified maize. Period. I have no regrets. How many of you cooked with the canola or cooked with oil? You know, say I want to get vegetable oil. Rapeseed. 99% of canola seed is GM canola or rapeseed. And that is where we are talking about the production of oil. I'm not telling you to be afraid. There's nothing to be afraid about. Utafiti umefanywa na wenzetu. That's why the purpose, why you saw that communique from WHO and FAO, was to dispel the negatives that people have been alluding that, oh, this will kill you. No, there's nothing. I personally, I fed on GM 1992. Before cooking it, by the way. And I'm still alive. I think this man is still healthy enough. He can run around. And I have not, it's true. I fed on GM and I believe in GM because there's nothing wrong with it. Because it improved the farmer's income, the region I was working threefold. Which farmer will not be happy to earn 3 times what they used to earn? Let's not bury their hand under the side. Let's help our people. Let's communicate and communicate properly. And if you have questions, we ask each other and sort it out. These are our sons and daughters who are doing this research. Mushid is our yours. It's not somebody from else coming to tell you because he knows he can protect his own people. I think for me, that's where I ended at that point. And we are here for you. We came back home so that together we can develop and protect our people. Thank you.
Thank you, Professor. Just as a parting shot, some of us think Europe is not into the technology. Actually, if you go today to Britain, you see this tomato, you're more likely to eat a gene-edited tomato. That is Britain for you. So let us not listen some of these hearsays, and let's go by facts. Because I remembered, because you talked about the nutritional aspect. Remember, in temperate, they have longer period of darkness. And in that space, they end up lacking what we call the vitamin D. It's not like for us, we wake up every day and you don't care. Because somehow sunshine will meet with you. If it's not within Nairobi or wherever, somewhere sunshine will get up with you. But for them, they're always in-house because of winter and also the long times for when there's darkness, and therefore they end up lacking vitamin D. So they are doing editing so that the tomato, that is Britain for you. But we have always been told, oh, Europe, oh, they don't eat, they don't do this. No, the truth is global. Now from Britain to US, to China, to Brazil, to India, wherever you go to West Africa. Actually, West Africa have overtaken us, which is a tragedy. Because for us as a country, we were far much ahead. But because of the drug, the West African countries have come and taken the technology. I can give you the example of maize. Nigeria just came and they said Kenya has done the science. This is a true fact because we are in the same project.
Nigeria, they went and commercialized. As we were left, we are still struggling to give the same variety to the farmer. Nigeria went and decided we are giving the farmer. So they never bothered with doing the science Caro has already done. So they already went to national performance trial, and the next season they gave the farmers, as we are struggling up today. So it's us to think and do a retrospective aspect as a country and see, do we let other countries now take lead? Whereas we were the country that was leading in Africa. Actually, when you talked in terms of capacity, in terms of the number of scientists trained, capacity to do, in Africa, you can only talk about South Africa, Kenya, and Egypt. Right now, actually, Ethiopia has overtaken us. Whoever want to go and visit Ethiopia can go and check. They have deliberately decided as a government to invest in it. Their labs are now international standards because it's a country that has decided to become deliberate. And I'm telling you, we are watching our neighbors. We'll be getting now products from Ethiopia. That's what this space as we drag our feet.
Thank you very much indeed, gentlemen and a lady. I know there are a lot of questions from the audience, but unfortunately, time is not on our side. But that does not mean the end of the discussion. We can always take it offline using social media platforms. Post those questions, tag all these organizations, ISA, AfriCenter, the National Biosafety Authority, CalRO, and all the rest of it. Please, let's keep the conversation going. But before we wind up, because we said there is the legislative aspect of this particular agenda, we were also joined by members of IALA, the East Africa Legislative Assembly. We'd just like to give them a minute each to introduce themselves, the country that they come from, and their take on today's deliberations, if you don't mind, please.
Good evening. Yeah, I'm really very glad to be part of this conversation. And first of all, I would like to congratulate Madam Dr. Margaret for inviting us. And you know, it's such an eye-opener. I'm by the name of Sadia James Sebit from South Sudan, Iyala member. So from where I stand, like from South Sudan, you know, being one country before with Sudan, so we really, you know, we have really, you know, seen the benefit, though some of us were young, but we could see, you know, what they are doing, especially in the cotton industry. So clothing was so cheap, you know, up to now, you know, things from Sudan, the clothing, they are very, very cheap, you know, and these are the benefit because they had tapped into the benefit. But from our side, South Sudan, you know, this perspective issue is still there. So as I can say it, as a legislator, the gap between the scientists and the laymen is really so wider. You see, you could tell us, we can talk to ourselves, but then, you know, the local farmers out there, they can't because, you know, the ordinary citizens, they could imagine of cancer. If I consume such a product, I would get cancer in 3 years. So being an ordinary citizen, it is very expensive to cure cancer. So it's only those ones of the privilege that can afford to go outside the country, abroad to treat themselves. So this perspective issue of cancer is very serious issue. So though we can say it, like for some of us who would say it, let us do for something like cotton. But other things we don't do. But you know, from listening from you is really an eye-opener. So as a legislator, we really need to, you know, engage more. And also I'm from CTI committee. We were two, but Falhad is just out from Kenya. So, you know, most of our members, they are so interested to be afforded the opportunity to come. So I believe next time you can take it to IALA, so maybe committee by committee, that would really help because we all come from different countries and engaging on that note will really help us, our perspective, because we really need to sensitize the local people. So it's really very important that we look at it in this 24th century so that we can address other issues that could help us, you know, progress with development agenda. So with that, I really thank you so much.
Thank you very much indeed, all the way from South Sudan. We appreciate you. You can pass on the mic.
Good evening, everyone. Indeed, it's been a pleasure to sit in here. I would like also to thank you, Dr. Margaret, for inviting the East African legislators, particularly the important committees that are relevant to this topic, and that is Agriculture Committee, which I myself and my colleague in front come from, and then the Committee on Trade. My name's Mary Mujenyi. I come from Uganda, and I'm one of the legislators. It was very interesting to hear the suspicion between members of the community, the farmers, and the politicians. Let me just clarify that much of what the politicians do in this particular, let's take an example, this particular topic of GMOs, we actually think that we are trying to protect our communities. And that is why it is important that our own scientists, like you are sitting there, you take the responsibility not only to do the research, but also to disseminate it properly, not only to farmers, but to the leadership like we are here. The issue of GMOs is a very important debate in the community. Even in Yala, as a parliament, we don't know what to do. And the lobby is actually equally powerful. There is a lobby against, there is a lobby in favor. There is also the fact that the science themselves have not harmonized so that they speak with one voice. You will get a professor who is promoting GMOs like you have done, and then you'll get others in another session who have organized with funding equally to talk against GMOs. So that's an area that you need to think about. So in your dissemination as well, you also need to show us the possible negatives and positives. For example, we sat here. You actually talked about only the benefits of GMOs. But really, with any scientific development, there are likely to be some negative impact out of the development of science and technology. So it's important, although it is minor, for us, particularly when we are listening to our own, which is important, that you also say, to mitigate the possible effects, this is what needs to be done. The whole issue of seeds is a very serious debate. That's where the biggest scare is. And I'm glad that you are talking about it. I'm sorry there isn't much time, but I would also like to invite you to come and address YALA members because we speak for the community. And also to do a network that touches all the scientists in the community. I thank you, and thank you for inviting us.
Thank you very much indeed. We do appreciate you very much. Your other colleagues are out. Are they here? Where is that? Okay. Welcome, sir.
Thank you very much. My name's Abdullah Makame. I'm a member of the East African Legislative Assembly from Tanzania. And it's been a great pleasure to have been invited here to represent our colleagues and the Assembly. We came here as nominated members because on behalf of our colleagues also from the Assembly. And arriving here, I met Professor Maja, whom we met a few years ago, maybe 2 years ago, I think, in Zanzibar. Then I said, this is a very safe territory. And to dispel the fears of my brother who said that the politicians were here and they went away, we are still around. And we don't walk away. We never do. Now, the issue about GMOs. We believe in science, technology, and innovation. We believe that whatever innovation is being taken for the interest of enhancing, so that we have better livelihoods, the spirit. And that is why we're having internet now, we're having self-driven cars now in the market. That's very positive about it. But also we're having atomic energy, we're having, which is very good, but also they are using the atomic bombs to kill people. They are using technology to kill people, to advance war. So with technology, as my sister Honorable Mugenyi said, it's like a saw. Ikienda mbele inakata, ikirudi nyuma inakata. Now where you want it to cut, but it has the pros and cons. Earlier in the discussion here, we were told that we can trust FAO and WHO. Yes, we used to do that very much, a lot, until recently in the year of COVID, when we were told that WHO misbehaved. And to that extent, we are seeing the leading member of WHO withdrawing from membership and withdrawing support to WHO, just because of the scandal for COVID. And still the world is divided. Some others think that COVID was real and others think that COVID was not real. Now, sitting on the table or on the position as a member of Legislative Assembly, you will hear the ones who are pro-GMO, and you will also hear the ones who are against. And we've had the pro. Now let me tell you the ones we had against, who are saying against. What were they saying? They were saying that now the advanced world wants to control us, Africa. And how they are going to control us? They want to control us using two things: the intellectual property rights. Intellectual property rights in terms of seeds, production and multiplication, and in terms of medicine. So they say GMO, when we get GMO seed, we plant it in our soil. In the previous years, we used the native seed. You plant, you have storage for seed, you'll plant next year. But for the GMO seed, you can't plant next year, you have to go and buy. That is number one. And number two, the GMO seed that has been planted in the soil, once it germinates, then if you bring the native seed to plant it again there, it won't grow. Because that soil will have already been overtaken by the GMO seed. Now those are the stories which we hear at the Legislative Assembly. And we also hear the positive, like the ones we've had here. And those are the debates which my sister is saying are coming from people in the field, not us. But assume now, if you are in the position like us, and you have to debate something that you think you use your rational reasoning to make a recommendation on policy, what would you have done? Because we are in this debate it has not been concluded, and the conversation is ongoing. And we are saying that we need to dispel and demystify the issues around GMOs. We have to create confidence. Now it's good. Now, you know, my friend, I've been friends with my sister Odemba here, because we came with her from where we are coming. We came together, and she's doing GMOs in cotton in Busia, and she's very positive about it, which is very positive. Nimemsikia na yule mama Kikamba yule anazungumza habari ya mahindi which is very positive. Now we need more stories from the players who are actually practicing upper. With the products coming from outside, we are consuming. Now that one of cancer and other things, you know, the other one they say it goes. Those are stories we've had, but these things we consume every day. They are there in the supermarkets. We consume grapes, we consume apples, we consume oranges. They are there. But what the fear, I can tell you, if you can demystify the fear of us using the GMO seeds in the soil and say that our soil is going to also remain as fertile even if we come and plant the native seeds again. Because that is the thing, we are saying that we are now selling our sovereignty to produce food, and we need to have food sovereignty. If someone is controlling you, even what you should produce, they say if these people are not towing the line, we are not going to sell them seed. So now with the issue, now the professor, my brother, is saying we need to have our own seed production. Now that is a breakthrough, because we don't want those people who are producing seeds from Europe and America to come and sell us seeds and then to tell us that now we are not going to sell you seeds, and so you won't eat, you'll die of hunger. We want to have our own seed productions, but even if it's going to be GMO and if there's going to be something like intellectual property rights on it, but to make it accessible easily to the farming population, so that we are not held hostage by multinational corporations. So that is the issue which we had been debating, and you can see maybe I've covered some ground which you might be informed now that we have been engaging with the GMO players in the region. And it's not that we are not pro-science. We are very much pro-science. We are very supportive, and we will be more supportive. But we want, you know, there was a story again. We had, when we were outside there, just prior to coming, we were with the professor who just left. He gave a story about the inking of the law, that you have to make sure that we control that noise. So let's get rid of that noise. Thank you very much. Asanteni.
Thank you very much indeed. Asante sana. I think hapo itatosha kwa leo. I'll see you,
We can respond.
Dr. Margaret. Muda umetupa kisogo.
Probably 5 minutes just to respond.
Mm-hmm.
Because I think we are responsible scientists, and we need to give our parliament, the policymakers, comfort, which I think is what they are calling for. Yeah. So there are issues which they have raised, which I don't think it will take 5 minutes even to answer, because it's as simple as saying, oh, what has been listed is not true.
Make it 1 minute.
Number one, GMO seed cannot reproduce is not true. There is no seed in this world today being made which cannot reproduce. That has been a falsehood sold by other people, but I can assure you there is no seed like that. I normally say whoever will find it can come to our labs and we can test. We have the facilities. Let us actually prove this thing. But people have claimed that it exists. There is nothing called GMOs which do not reproduce. So that is not true. Soil contamination, also not true. Remember, we are bringing in the same varieties the farmer has been having. That variety is only being made to be advanced. In fact, as scientists, the main challenge we have been facing is to answer that question. Give us the negative about the product. You see, for us, it's like asking us, you have a phone, isn't it? You have just downloaded another app to serve you on something.
What has changed in that phone? Does that phone now become dangerous? You have just added a trait to an already existing crop. And that is why I said the same varieties the maize farmers, actually the varieties, and they are gazetted in Kenya, the ones that have been released, those 3 varieties are with the farmers. So it's the same variety, but we have added the attribute of being pest resistant and others disease resistant. So actually there is nothing you are altering. The issue of sterility, we normally say as scientists, that will be a discovery. Actually, we will not even sell it as food. We sell it as a pharmaceutical product. There is more money in pharmaceutical industry. I can assure you, if GMOs were doing that, we will not give you as food. We'll give you as a pharmaceutical product, because that is one of the main things that is being used out there. So those are falsehoods. They're called what theories? They're just theories created by people, but there's no truthfulness in it. So sometimes when people bring them and say they are the negative aspect of GMOs, the scientists are not saying, how do we now start telling you falsehoods? Because they are not scientific. What we normally say in science, bring you a statement that actually can qualify. The question of cancer, and I think that is what I'll end with, is something which was created some years back in 2012. And actually is what led to Kenya doing the banning aspect, bringing the ban. And it's because there was a scientist who decided also to misbehave and to do science not following the right principles. He actually went and chose mice that are used for research for tumors and fed on them the corn maize, the glyphosate resistant. And basically by doing that, those mice, even if you had given them water, they would have still developed the tumors. And actually that paper was retracted. It was by Seralini. You can even Google it. And actually it is just published there with an exclaimer on how not to do science. It is retracted. And actually, EU commissioned a study to see if that professor was right. And actually in 2016, EU published and actually said that paper was at fault. And that is why up to today, there has never been any link between the use of GM crops and cancer. It doesn't exist. So these things are claims which are false and they don't have a standing scientifically because they have been proven. Because if you claim all the foods can be able to cause, remember I talked about the same varieties. The same maize, the DK777, is the one you'll get. But now with the additional trait. And if we say food produces cancer, it is not true. Because even cancer itself, moderator, just in a minute, actually people don't want to explain to general populace what cancer is. And in general terms, it's a genetic deformity. Cancer, by definition in itself, is just a genetic deformity. Because remember, when I started my presentation, I talked about if it's a growth hormone, it has a start and stop, isn't it? So when you affect the gene part that controls the stop, the production will continue. And that is normally what happens. And we know the causes of cancer. We have irradiation. Remember I talked about radiation being able to penetrate. That's why you are told to avoid a lot of UV light. And even X-ray, that's why the procedure for X-ray is quite stringent, because it is affecting the genome. Then we have chemicals which are known that they can be able to interact with the genome. So there's a whole profile. When you go to WHO website and look for those chemicals that can cause cancer, they're well listed because they have been characterized. The other thing are viruses. We understand because the viruses, and that goes to the first question about organisms, and it was only said to be plants and animals. And I said we are halfway because even bacteria are part of organisms. The viruses are also part of organisms. But the viruses, what they do is they don't replicate on themselves. When they invade you, when you get a flu, the virus, what is doing, it is entering into epithelial cells and commandeering your DNA and using it, your DNA, to multiply itself.
So in that process, when they multiply, your cells die. And that is why you fall sick. That's how the system goes. So we have viruses, like the one for women, the one that causes the cervical cancer. We already know. We know HIV causes the skin cancer. So these viruses, if they interfere in the wrong segment of the genome, then they can lead to cancer. The other one is what you normally say is just a normal inheritance. There are families that are predisposed. After some time, there will be a deformity. That one you have no control. And that is why you'll find cancers falling within a lineage. Because these things are known. So sometimes when people claim things are causing cancer, it's a fallacy. We can be able to characterize and pinpoint if there is any causative agent. So from a scientific point of view, we can be able to explain if cancer is actually being caused by GMO. That is what I was driving at. Because we have all the procedures to be able to determine that cancer was actually caused by GMO. So if you go and look, probably all of us, we go and look for any cancer out there that can be linked to GMO, probably I would resign my job.
Thank you very much.
Because actually there is
Brother Aksari.
nothing like
Thank you
that.
very much. I know we can never finish these discussions because they are emotive, they're enlightening, but then again, that's a challenge to you, the organizers, to keep having such kind of fora so that these issues can be talked out extensively. All right? Allow us to bring today's meeting to an end, but before that, I'd like to call on stage Calvins Odero from Kefis, who'll give us a vote of thanks, and shortly thereafter, we will be dismissed. Of course, because people need to go attend to other matters urgently. Thank you very much for your time, the panelists. That was quite amazing.
Hello, everyone. Hello. I see we look so tired and exhausted, but full of knowledge. We are not here the same way we came. I know we have picked one or two things that now when we go outside there, when we talk modern biotechnology, we'll be talking out of knowledge, not out of hearsay. So in the Thanksgiving portion, I would like to first thank the congregants, whoever made time to come here, to hear whatever thing that we have to discuss here. It is not really something that we can overlook, that you set time to come and be with us here. And another thing that is coming out very clearly, we are realizing that misinformation on modern biotechnology is a shared role. Misinformation is a shared role. Each and every person has got a role to play in dispersing the misinformation. Whether we talk of researchers, researchers can also spread misinformation. Yeah, that's why when our representation from Yala was talking about some scientists talking about a GMO in an advantage point of view, others are talking about it in a disadvantage point of view. So researchers have a part to play. We also have regulators who are here. Regulators has a part to play. We have the students who are here. We have policymakers. We even have the media here, who also has a role to play. We also have the Gen Zs, who also have a role to play. Yeah. So each one and every one of us, we need to know that when we come from this place, you have a role to play in terms of demystifying modern biotechnology and demystifying whatever people are talking about GMO. And you have to instill the fact that we need to talk out of data. We need to talk out of a know-how from what we are giving out. So specifically, I would like to give a vote of thanks to Dr. Margaret Karembu, who is the organizer of such a beautiful event. Yeah? Without her, I don't think whether we'll be here. Without her, I don't think whether we'll be talking about modern biotechnology at this particular time. Thank you so much. And I think you will be, if you will organize such, in a frequent basis, so that we also have larger groups. Then we demystify this. However much we are saying that whatever we do in 10 years can be brought to, can be destroyed in a second by people who own the microphones. We just have to do what we do. So we thank you so much for organizing this. I would also like to thank the National Biosafety Authority, represented by Dr. Muchiri, for having been here to break down and tell us what the technology is about and tell us everything about the litigations that are there and how they are handling the litigations to the end to ensure that the farmers at the end get the varieties that they are really yearning for. I would also like to thank the Kenya National Academy of Science for being here with us. Then I would also like to thank the Kenya Agricultural Research Institute, that's KALRO, represented by Dr. Muriigi. Dr. Muriigi, that was a very good presentation. It was the best. I've never had such. When you broke down all that technology, all of it, you broke it so simply that anybody who has never been in a genetics class should be able to now understand what TT is, what small t is, capital C. I know everybody here is now a geneticist, and they can talk about genetics in a very comfortable manner and in a knowledge point of view. Thank you so much for that presentation. I would also like to thank the African Science Dialogue, and I will also not forget to thank the YALA team who are here, our very good friends. But my friend, as you go to the YALA, you also need to tell them to trust the process. They are some of the people, you are the people who make these laws, and then you have entrusted these laws to the executive. We are there to implement the laws. And whoever is implementing these laws, they are also scientists. You see that? I am a biotechnologist by profession. So when I'm at KEFIS regulating biotechnology, you know that I'm doing the correct work. So when I present and I tell you, oh, this is correct, before we go with the misinformation, come to the agencies, sit with the CEOs, discuss with them. They will give you the real information so that when you go to the general public, we know you are good as there. When now you tell them, I have gone and I've talked to KEFIS, I've talked to NBA, I've been to ISA, and I've had a coffee with Dr. Karembu, and whatever he's talking about GMO, I think whatever these people are talking about is not correct. You see? Then you will be talking from a data point of view. Yeah? And that will really take us a step further so that we are not left behind when others are moving forward. We are left stagnant at a point that when now we start rushing in implementing this technology, others shall have already reaped the benefits to an extent that we cannot catch up. When Daktari was presenting, you realize that we are still debating transgenic. While we are debating transgenic, we are now in genome editing. So while we still debate transgenic, other technologies will be coming. So see a way where we'll be implementing transgenic when others have already gone a step further. You see that? So as we have this, as we discuss this misinformation, let us talk from a point of view that is based on data and science. And that, I think, will go far. I would also like to congratulate and to thank our farmers who made their time to be here. They really made us understand and see the practicality of this technology. When a farmer from Kitui, when a farmer from Busia, specifically telling you that I used to plant cotton, and since this technology came, what has happened? The yield has increased. You see that? From this, we need to already start seeing the importance that is played by this particular technology. If this is what cotton, what would have been done by maize now? If we extended this to other crops like cassava, like Daktari, where I come from, when I was young, I used to see a lot of cassava. You see that? There was a lot of cassava. But now when I grew up, I realized that cassava is no more. Then I started asking myself, where did cassava go? But today you have answered it. I now know where cassava went.
But now I really need to be part of the team that is going to bring cassava back to my community. How am I going to make sure that? I'm going to make sure that it comes back by declaring and ensuring that misinformation on modern biotechnology is cleared so that we talk from a data point of view. With that few remarks, I forgot to thank my own organization, that is the Kenya Plant Health Inspectorate Service, that is represented by me and my colleagues there. We are also grateful for being invited to this a good forum that is discussing misfortunes in misinformation in modern biotechnology. Thank you so much, and thank you again. And when you are welcomed again to come, please, we welcome you. You come and we discuss modern biotechnology so that we can move forward with this technology. Thank you.
Very much indeed, Calvin's Odero from Kefis. See, that's the challenge of being a moderator or an MC. No one thanks you. So I take this opportunity to thank myself for having been part of this amazing deliberation, the national dialogue on GMOs in Kenya. And remember, the agenda was growing food and protecting the planet. That brings us to the end of today's meeting. We'll see you again when Dr. Margaret and the team organize the next forum. Mko tayari kwenda nyumbani? Si twende basi. Asanteni sana.